Thank you. You may all be seated, please. Thanks. Um,
Good morning, all. Good morning, everybody. We are all welcome to the day two of the workshop, and we appreciate all seated here. And also, on behalf of the organizers, we wish you all a successful deliberation, interaction, and we hope that what we are going to learn today, it will help us in our different organization. When we get back, we'll be able to interact and also share what we have learned with other of our colleagues. Please sit and listen, and also we want your input as we go. Thank you.
all right. Thank you, Engineer Inifong, the secretary for this young professional. Please permit me to welcome in our midst, Dr. Mukhtar Dembele. He is from International Water Management Institute. Please, round of applause. Just stand up. And Abdul Karim Ibrahim, they were here yesterday. He's from Interhydro Consultant Services. Please, a round of applause for him. Thank you, sir. You're welcome. Engineer Jafet Barnabas, FMITI. Please, a round of applause for him over there. You're welcome, sir. And Mark Oluwafemi Bedezi. Sorry if I didn't pronounce it properly. Welcome, sir. He's from Mark Femi Farmers Allied Service. Is it farm? Okay, Allied Services. Welcome. Welcome. So welcome, everybody. Today is another day for us to gain knowledge and interact amongst ourselves. Um, okay, we are going to start with um, The next section, that's today's section, will be Smart Irrigation System, Role of AI and Machine Learning. And the presenter will be Dr. Motau Dembele from IWMI. Please come up. Round of applause as he makes his way. Thank you. Sorry, please, we have engineer Dr. Adebayo, okay? He's in our midst. He's from IWMI, irrigation engineer. A round of applause for him, please. Thank you, sir. Welcome.
Okay, good morning, everybody. I'm Dr. Mokta Dembele. I work for the International Water Management Institute as a researcher in spatial hydrology. And I'm really pleased to be here today in Abuja and also attending this young professional forum to share some knowledge on the use of AI and machine learning for irrigation, monitoring or mapping, and also how to develop a specific tool that we have that is called the Vegetable Irrigation for Climate Resilience Toolkit. But maybe before we proceed further, I would like to know maybe the profile of the people who are also in the room. So if you can just give me your name and the institution where you are coming from and your background, just very, very, very briefly, so we know who we are talking to. Is the mic on?
Good morning, everyone. My name is Engineer Safia Aliu Mahmoud. I'm from Hadija Jama'ari River Basin Development Authority. Thank you. The chairman of the
Osman Khalil from Hadija Jamal River Basin Development Authority. I'm an irrigation engineer.
Thank you.
My name is Mark Uluafemi from Markfem Farms and Allied Services. I'm the lead feed personnel and irrigation expert.
Thank you.
Well, I am Engineer Japheth Barnabas from Federal Ministry of Industry, Trade and Investment.
Thank you, sir.
Good morning, all. I am Mohamed Maina, Engineer Mohamed Maina from Bayero University, Kano, an engineer in irrigation and drainage specialist. Thank you.
Thank you.
Good morning, all. My name is Engineer Abdulkadir Dauda Aliu, a lecturer with the National Water Resources Institute, Kaduna. Thank you. Irrigation engineer.
Good morning, all. My name is Inimfon, Engineer Inimfon Achibong from Federal Ministry of Water Resources, Department of Irrigation and Drainage.
Good morning, everybody. My name is Engineer Vivian Ikaka, Irrigation and Drainage Department, Federal Ministry of Water Resources.
Good morning, all. My name is Engineer Lawal Abdul Rahman, Federal Minister of Water Resources and Sanitation, Department of Irrigation and Drainage. Thank you.
Good morning, all. I am Engineer Hassan Osman Churoma from Federal Ministry of Water Resources and Sanitation under the Department of Irrigation and Drainage.
Good morning, all. My name is Abdul Karim Ibrahim, the CEO of Agency Services.
Good Good morning, everyone. My name is Taibat Fatai from Federal Ministry of Water Resources, Irrigation and Railway Department.
Good morning, all. I am Abdullahi Abdurrahman, Federal Ministry of Water Resources, and also the coordinator of the young professions in Nigeria. And we are all happy to be here, and we welcome you all for joining us. Thank you.
Good morning, everyone. My name is Ejina Ibrahim Abdullahi. I'm from Upper Niger River Basin Development Authority. I'm an agricultural resources engineer.
Morning, all. My name is Fansha Guid. I'm from Youth Water Sanitation and Hygiene under the Clean Nigeria campaign.
I think I've been introduced. I'm Adibayo Oke. I work with Mokta at the International Water Management Institute, Accra, Ghana. Thank you.
Okay, thank you very much. It's good to have an understanding of the profile of the people in the room. Can we go back to the slides, please? All right, next slide. So just quickly to introduce myself. So as I said, I work for the International Water Management Institute. I started there in 2021 as a researcher in spatial hydrology. Before that, I did my postdoc at the University of Oxford, looking at large-scale hydrological modeling and the impact of climate change on water resources. And before that, too, I was working also for the Africa Rice Center, which is a center, a CGR center, similar to IMI, but then focusing on rice. And I have a PhD in environmental sciences, focusing on large-scale hydrological modeling, water accounting, climate change impact from the University of Lausanne, environmental engineering, Burkina Faso, but I'm currently based in Ghana. And next to that, I'm also a member of the International Association for Hydrological Sciences, and I'm currently the chair of the Early Career Committee of that association. So you can understand why it was also really exciting and important for me to be part of this Young Professional Forum today. And I'm also the secretary of the Africa Regional Committee under that association. So membership to this association is free. We have different commissions working on surface water, groundwater, things related to irrigation. So if you are not yet part of it, I'll encourage you to join this. It's easy to find it online. If you type IHS online, you will find this. Membership is free, so you are very welcome to register if you're interested. Next slide, please. So I also want to briefly talk about the International Water Management Institute, what we are doing. So it's a research for development center, which is part of a global consortium of research centers that is called the CGIAR. What we do is mainly research for development, but focusing on our part on delivering evidence-based approaches and water solutions for sustainable climate resilience development. Our headquarters is in Sri Lanka, Colombo, but then we have regional centers around the world. The regional representation for West Africa is based in Ghana, in Accra, but we are also planning to open an office very soon in Nigeria here. I think in Pubwa, Bayo, that's the name, Pubwa. So in the coming days or weeks, we'll be having a presence officially here in Nigeria. And then IMI works on 4 strategic programs. The first one is water, food, and ecosystem, where we focus mainly on issues related to food security. The second scientific program is water, climate change and resilience, where we look at water risk related to climate change. And the third strategic program is water growth and inclusion, where we look at how to make sure that the benefits of water resources are equitably shared among the different social groups. And the last scientific or strategic program is called the Water Data Science and Digital Innovation, where we look at leveraging geospatial data and machine learning, artificial intelligence technologies for water resources management. Next slide. So to start this presentation, I would like to give some background. So the map that we are seeing here is actually the current state of rain-fed and irrigated areas in Africa. So as you can see here, if you can read the legend, so in orange and yellow, we have the irrigated areas, and red as well, and the other colors, mainly the pink and the purple, represent rain-fed areas. So what you can see here is that most of the regions in Africa are mainly under rain-fed condition, which is not that interesting in terms of boosting food security, when we know how rainfall is not that reliable across the continent. Next. And then this is a map of the potential for doing irrigation in Africa. So you can look at the difference. You see that what this map is presenting here is the vast opportunity that we have to expand irrigation across the continent. Next. And the final map here is looking at the potential of irrigation expansion, but using renewable groundwater resources across the continent. So you see that in terms of using renewable groundwater resources for irrigation expansion, there is a huge potential for it also across the continent. And you can also see how this is represented here in Nigeria. Next. So the potential of untapped groundwater is therefore very huge in Africa, and this can definitely support farmer-led irrigation, and also enhance the resilience to climate change, and also drive food security across the continent. Next. So looking at farmer-led irrigation, this is a dynamic approach where farmers take the initiative to establish and also improve and expand irrigated agriculture. And when we focus on vegetables, I will mainly look at vegetables here, because the tool that we are developing, and that I'm going to present in more detail, is focusing on vegetable. What we notice is that vegetable used to be produced mainly under rain-fed conditions. But then with farmer-led irrigation development, they realized that we could easily increase crop yields with irrigation, and therefore there has been an increase in irrigation water supply for vegetable production. For instance, looking at the statistic from 2018, it is estimated that about that vegetable consumption per capita is about 386 gram per day, and then this represents about 146 kilogram per capita per year. And if you multiply this by the average water footprint of vegetable and fruits globally, which is about 1,623 liter per kilogram, and also considering the global population of about 8 billion people, we therefore have a global water footprint of vegetable and fruits that is estimated to be about 1,941 cubic kilometer per year, representing about 1/3 of the global water footprint for crop production. And these numbers are expected to increase in the future. By 2030, we expect to have an increase of about 36% of the global water footprint for crop production. Next slide, please. So here, what I'm showing is the global state of irrigation sustainability among different regions in the world. So you can see in red the locations where we have groundwater depletion, and in green the locations where we have mainly surface water depletion. And also you can see how sustainable water is being used around the world, and it's estimated that only 50% of irrigation is actually sustainable. When it comes to looking at unsustainable water consumption per crop, what we notice here is that vegetable is the 4th largest group for unsustainable irrigation, only next to wheat, rice, and maize. So there is something to be done here. Even though we want to promote irrigation, we want to make sure that the water is being used sustainably, so that we don't overuse the water, and then that also might bring further implications for the environment. Next slide, please. So how can we support sustainable expansion of farmer-led irrigation development for high-value crops, including rice, maize, vegetables, and so on and so forth? So in our approach here, we propose a 3-step approach to foster the use of renewable water resources, but taking into account the fact the water that is available that we can use, and then to avoid over abstraction of water that can definitely lead to hydrological imbalance. So we have 3 steps, as I mentioned. The first step is vegetable suitability mapping using machine learning. And the next step is sustainable water limit. So after understanding where the land is suitable for crop production, then the next step is to understand what are the water limits for crop production, being for surface water, being for also groundwater. After that, after knowing where the land is suitable, how much water we have for crop production, we also want to now know which irrigation technology can we use for crop production. So we've integrated these 3-step approach within a tool that we call the Vegetable Irrigation for Climate Resilience Toolkit that I'll be presenting in more detail. Next slide, please. So let's start with the first step, the suitability mapping. Next. So I have questions for you. I want to know how to describe land suitable for agriculture. I want this session to be a bit more interactive. I know there are some contents that I'll have to probably skip or spend less time on it because of the delay that we have. And then, yeah.
When the land is productive. You know, I remember this adage in school. It's all fertile lands are productive, but not all productive lands are fertile. Something like that. So, yeah.
Mention fertility. You want to add something? Any other answers?
Fertility of a land to be suitable for farming.
And when do we consider that the land is fertile? Either that question or the 2 other questions.
The land is fertile when there is when the land doesn't have a lot of salt, that's the pH. So when there is no salt, that will hinder the type of crop you want to plant. So the resistivity of the crop, and then the land is fertile when whatever you plant will germinate and will produce to the expectation.
A land is said to be fertile and suitable for crop production when it has all the necessary nutrients, macro and microorganisms to support the growth of plants. That is when it is said to be fertile.
All right, thank you. I was just about making comments about the nutrients. A land is fertile when the soil profile is suitable for the crop you want to cultivate on the land in terms of the NPK value, the salt, the silt, the magnesium, and other micro elements that could be present. Some lands could be suitable for a particular crop and it's not suitable for that crop, referring to pH. Certain pH are not suitable for vegetables, but they can go for cassava, maize, rice, millet, sorghum, and the likes like that. So that is the land is fertile.
Excellent, thank you. I realize I only have experts in the room. Next slide, please. Yes, so here is a definition. So land suitability refers mainly to the assessment of how appropriate a piece of land is for a specific use. So if the use is agriculture, forestry, or urban development, then it's all about evaluating the land characteristic to see if they match the requirements of the intended activity. And when it comes to agriculture, this means looking at whether the land can support crop growth or livestock rearing effectively and sustainably. So the land is considered suitable for agriculture when it meets several key criteria that can support plant growth and farming activities. So rightly as you just mentioned. Next, please. Do you have a pointer that I can pass myself? That I can use to skip the slides? You don't? You get one. Yes. So now I want to understand, based on this description, what are the factors that determine agricultural land suitability for crop production? Based on this description. What are the factors that determine agricultural land suitability?
The land must be properly drained. Maybe you just say drainage. Yes.
That's mainly the soil condition. All right. Okay. Anything else?
Presence of elements in the soil like calciums, potassium, and other elements that are suitable for crop production should be present in the soil.
So nutrients. Anybody else? I see you want to say something. Nutrients? All right, next please. Topography? Topography as well? Okay, good. Anything else? Climate as well? Okay. Water? Water availability? Good. Anything else? Sorry? Land reuse? Good. Anything else? Accessibility. What do you mean by accessibility? Accessible. Physically accessible. Excellent. That's good. So those are some of the socioeconomic factors. All right. Next, please. Next slide. Yes, so I think you were right. So these are some of the factors we need to consider to assess land suitability, like the quality of the soil, and there are different elements there. I'm not going to cite all of this. Then the next one is also climate. It's good to have a good climate condition in terms of rainfall, temperature, sunlight exposure. Topography, he mentioned, that's also very, very important. Then water availability of course, that is key. And then also pests and disease. We need to make sure that there is a lower natural pest and pathogen prevalence. Next slide, please. But what is here, what we see are mainly biophysical factors, but there are also socioeconomic factors. Next, please. Yeah, and these are some of the socioeconomic factors. So access to the resources, so proximity to labor, to markets, and also infrastructure. Sometimes availability of credit, affordable loans, and also subsidies facilitate investment, economic viability, land tenure, risk management also sometimes, and land use history is also very, very important. If the land is contaminated, you cannot do much with it. And also some cultural and social factors like traditional practices or also community support. If there are cooperative that work together, for instance, for crop production. Next slide. So knowing now what land suitability is and also the factors that determine land suitability, if you were asked to do land suitability mapping for a given region, how will you do it? If you were asked to do land suitability mapping for a given region, how will you do it? Are there some people here working with remote sensing, GIS, those kind of things? Nobody? Okay. Yeah.
Number one, look at the rainfall pattern. Climate data.
Climate, you know that you have to look at topography, you have to look at soil, you even have some socioeconomic factors that you have to look at. Knowing all this, if you have to do a map of the area, to know the land suitability of that area, how will you proceed? My brother here wants to say something.
Thank you. First of all, the crop or the intention has to be known first. I guess that's what I will start from. When I know what kind of, for instance, for agricultural purpose, if I know what kind of crop is going to be cultivated on the land, and I know the nutrient requirement, that would determine the mapping. For instance, if you have an acre of land and if you have 10 hectares of land, the soil profile will vary at some point. So I will start from the aspect of what kind of crop am I cultivating, and if the land suitable, from the previous question we asked, if the land is suitable for that kind of crop, that will determine I'm going to map it out. I guess that's my own view for now.
Excellent, yeah.
I think with addition with that, maybe we have to look at the availability of the ground and surface water before we even start going for that land.
But then what I want here, we talked about presenting the definition of land suitability. That was the first one. Second thing, we talked about the factors that determine land suitability. But now, knowing this and having this information, how in practice do you generate a map of land suitability for a given region? Which techniques, which approaches do you use to generate the map of that area? Yes.
I think we also need to run some soil tests to know the soil texture and structure.
Yeah, but will that help you get the map to put the map on a paper?
Okay, we need to take coordinates first.
You do what?
The coordinates,
Uh-huh.
coordinates of the land.
Yeah.
Before we can put it in on GIS,
Mhm.
we need to take the coordinates to know the longitude and latitude. That's the location
Of the region.
of the region.
Land survey, okay?
Land survey, yes.
Okay.
To know the topography, the level, take the topo map.
Okay. All right. We are not there fully yet. We are not there yet fully, but I think we are getting closer. You wanted to say something? No? It's fine. All right. Yeah.
That's what you're saying.
Yeah.
You need to do a land survey,
Mhm.
and using GIS, that will help us to know, number one, if we have contours, if we have ditch, if we have valleys in between, if we have if the topography of the land will also tell us on how to put it on the map. If what we have, for instance, we want to take a survey of Sheraton, where we are at the moment, to represent it on paper, so that if anybody picks it up, it could tell, okay, by this map, I guess we can't do anything in this area, maybe because of a ditch and stuff like that, or something like that. I guess that's what we're referring to. So it's survey, and let me say remote sensing could help you get that interpreted on a paper, such that anywhere you take it to, you could have an idea of what the lands there look like and what could be proposed. Thank you.
Excellent. Good. So next, can you put back the slide? Yes. So conventionally or traditionally, this is how it's done. So then you first define the study aim. As some people mentioned, you need to know the crop that you are looking at, right? You choose your crop first. If it's any kind of vegetable, if it's tomato, onion, cucumber, or whatever, you have that. You know the location. And then you also know the time frame over which you want to do the analysis. Then you look at relevant environmental criteria, like some of the factors that we mentioned. So you can look at climate, soil, and topography. And then in the approach, how it works, using GIS and remote sensing here, you have to do a standardization of the criteria, right, to put them in the same range so that you can easily compare. And after that, you have to do a weighing of the different criteria, because maybe climate is more important than soil quality, or soil quality is more important than topography, or water availability is more important than the socioeconomic factors, and so on and so forth. So you can do that. And then after that, after doing those rescaling, you can now weigh the different criteria and get your suitability, land suitability map. But this is the way it is done traditionally using GIS. But this approach has some drawbacks. And those drawbacks are high subjectivity. And this approach is what we call the multi-criteria analysis approach, because you have multiple criteria that you analyze, you weigh them, and then you get your suitability mapping. But if you have to take different experts here to look at different experts, even first to choose the environmental criteria, different people will come with different criteria selection. Also, the way you put weight on the different criteria, different experts will put different weight on the different criteria. So at the end, if you give this same task to different experts, you will end up with different answers. So then machine learning is coming here, or artificial intelligence, with a way to avoid this high subjectivity component of the multi-criteria approach. So next to the multi-criteria approach, there is another approach that we can use for land stability mapping using artificial intelligence and also machine learning. So this is how it goes. So this is not a course on artificial intelligence and machine learning, but I'm just going to give some background on it so that we have a good understanding of what we are doing. So artificial intelligence here is the broader concept of enabling a machine or a system to sense, reason, act, or adapt like a human. And then machine learning is a subcomponent of artificial intelligence. So if artificial intelligence was an umbrella, machine learning will just be under artificial intelligence. And within machine learning, you also have different techniques like neural networks and also deep learnings that are more advanced technologies for machine learning. And machine learning here is defined as an application of AI that allows machines to extract knowledge from data, and learn from it autonomously without being explicitly programmed, right? And the ML, the machine learning algorithm, analyze and identify patterns, relationships, and trends within the data, and then use these insights to build a mathematical model. This is very important. So the data that you provide to the machine learning algorithm, the algorithm will learn from that data and then builds a mathematical model based on the data you are giving to it. And then from there, you can use that model to make predictions and also take actions when presented with new and unseen data. So first, you train the model, or you develop the machine algorithm model looking at existing data. And when the data is not available or for new conditions, you can use the same model to do predictions. So here I will show how we can use machine learning to do land suitability mapping. So if you recall, I don't know, is there any pointer? Can I? No, it's not coming, but that's fine. So on the left-hand side, you have the conventional approach using GIS multi-criteria analysis. And on the right-hand side, you have the modern machine learning approach. So the main difference here is that when you use the conventional approach, you are limited with the number of input data that you can use. Because the more input data you put in, the more complex it becomes to do the analysis. But when it's coming to the machine learning side, you can put as much input data as you want, and that will work. But what you will need here is to have, is this one? All right. No, it won't work on this type of support. All right. Then after defining your criteria, or what we also call the covariates, then you need to have some ground truthing data, right? It can be yield data, or it can just be the locations of where the crop is being produced, right? And then you can develop now your machine learning model and use a given machine learning algorithm that will develop a nonlinear relationship between the input data and the covariates that you are putting in the model. And from there, you can do some accuracy assessment. While in the conventional approach, you cannot do accuracy assessment. So that's also a limitation of that conventional approach. And the advantage of machine learning is that you can scale it. It's scalable, right? Because if you, for instance, you go with the conventional multi-criteria analysis, you do it here for a region in Nigeria, and you want to scale it for another region in Ghana, it might be difficult. You might have to start the process from scratch because the local realities might be different, right? The prevailing natural conditions will be different. So you will need the expert again to come together and rethink about the whole process. But when we go with the machine learning, you can develop that for a given region, and when it's working well, you can scale it up to other regions. So these are the types of machine learning technologies that we have. So in machine learning, we have mainly four types. The first type is supervised learning, where we can train a model on labeled data sets. So you choose that approach when you know, when you have some ground truthing data. So you already know the correct answer. So based on the input data, you match the input data with the output data, and the machine learning algorithm will develop the mathematical model based on that, and then you can use that model for prediction. And under the supervised learning approach, we have two subcategories. The first one is what we call classification. And the classification approach that is used for categorical variables. So if you want to, for instance, know if there will be rain or not. This is categorical information. And then regression is used when the output is a real or continuous value. For example, if you're interested in knowing the rainfall amount or the crop yield, for instance. Then we have the second machine learning category, that is the unsupervised learning. And this is used when you don't know the information on the ground, but you want to cluster it. Let's say, for instance, you are in a given location, you don't know the different crop types, but you want the model to generate different clusters to tell you what are the different groups of crops that are there. Then the model can generate that. It won't be able to give you the name, but it might be able to differentiate in terms of pattern, to show you, okay, this is pattern A, this is pattern B, this is pattern C. Now it's up to you to go now and determine maybe what is rice on the ground, what is wheat, what is tomato, what is onion, for instance. Then the third category is what we call reinforcement learning. And this is specifically for models to make prediction by getting rewards or penalties based on actions performed within an environment. And this technology is used to train robots to perform tasks like walking around a room, for instance. And then the last category is what we call generative AI. And I guess most of you are using this today. So all the ChatGPT, DeepSeek, Grok, those are based on this approach of machine learning. So now, knowing the different categories or techniques or system in machine learning, so if I had to ask you which model, which machine learning type shall we choose for our land suitability mapping, looking at the different options that we have here. So let's say now what we are interested in is to know on the ground where vegetable is being produced and where it's not being produced. So we just want a simple map. If we take, for instance, tomato, we want to generate a map of where tomato, where the land is suitable for tomato and where it's not suitable. So which technology will we choose here? We just want two options to know if the land is suitable for tomato or not. So which approach will you choose? Is it supervised learning? Is it unsupervised learning? Is it reinforcement learning? Then if it's supervised learning, will it be classification or will it be regression? And the other, we only have one option, either clustering or reinforcement learning. Sorry? Okay, you want to say something.
Okay. Sorry. Go back to the slides, please. To me, it's supervised learning, and it should be classification. I said, to me, it's supervised learning, and it should be classification.
And classification. Supervised learning and classification. Do you agree with that? You agree with him? You go with reinforced learning. Why?
Because in reinforced learning, you allow the model to look at the environment, you give it the feedback that yes, it is suitable or no, it is not suitable. Then it will re-evaluate again and at the end of the day produce a model.
Okay, so now we have two options. Is there a third option? Is there a third option? Okay, otherwise we have to vote now, and based on that we'll proceed with the option that you've chosen. So, who are the people who will vote? So we have two options. We go with supervised learning and classification, option 1, or option 2, we go with reinforcement learning. Who are the people who are for option 1? Supervised learning, classification. You want to add a third option?
I want to understand the question. The question is based on what is suitable for either tomato or vegetable, right?
Yeah, I will reframe it. So the question is, I want to develop a land suitability map to know where the land is suitable for tomato or not. Very simple. I want to know if the land is suitable for tomato or not. So this is like, okay, if I say more, I might give some tips. So I'll leave it here. So option 1, supervised learning, classification. The guy even who proposed supervised learning is not voting. So he has changed your mind or what? You are the one who proposed. Now I asked to vote and then you don't want to.
Something.
Yeah.
I believe why I'm going supervised learning classification. Because number one, when you're doing your mapping, you're supervising and also you're also evaluating the land in the process. So I want to believe the activity of environmental and the like that have been put into consideration before this will come up. So supervised learning will be more because you need to do a thorough check of a place. So that's why I'm doing supervised learning classification. It's more detailed.
Okay. So option 1. Who are the people for option 1? Wow, okay. Supervised learning classification. Okay. People for option 2, reinforcement learning. 4 people. Okay, then we have to go with majority. If it's democracy, we go with the majority. And I think in this instance, majority is winning, and democracy seems to be a good option in this case. So we'll go with the first option. All right. Yeah. You are coming with third option? Are you coming with third option? No. Okay. Okay.
The two options has been identified.
Yeah.
And there you are the best scholar. You're supposed to tell us that this classification or their score.
I can tell you, but now that we say that we are going with the majority, if you choose a supervised learning classification, we go with that. If it's wrong, then we are all wrong. Right? So I will just trust you guys. What you choose, we go with that one. Okay? But that was the correct answer. So the correct answer is supervised learning classification. Because in this case, the task is very simple. It's about doing a categorical classification. We want to know if the land is suitable for tomato or not. So it's either yes or no. So this is a classification exercise. So we go with classification, supervised learning.
Well done, able resource personnel. Please permit me to introduce our ICID president, all the way from Italy, in person of Dr.
Matthew.
So, thank you very much. It's a pleasure for me to be here with you for several reasons. First of all, because this is my first time to Nigeria, so I'm very, very happy to be here to visit this beautiful country, and I'm sure that expectations will be fully accomplished because I've never been to this part of Africa. I've been, of course, to other countries, but never been to Nigeria. So I'm very happy to be here. From your communities and from your habits, your culture, and your traditions. But I'm very happy as well, allow me to say, to be here with you because you are young people, and I have the honor to be president of needs, young blood needs to have young and skilled and talented young professionals. So I've always been paying a lot of attention to the contribution that young people, young generation can bring, especially to an organization such as ICID. When I was a candidate in November 2023, I said that I would be strongly willing to strive for having two major goals. The involvement of young people in the organization, because you see, in my organization, you become a president usually when you retire from work, because you have to dedicate, of course, a lot of effort, a lot of time, traveling, a lot of energies. I'm coming actually from Oman now. I'm not coming from Italy, so I was there invited to another conference, the Oman Water Week, which was very interesting, and I'm sure that with you, we will have the chance, with all of you, or who of you are more interested, to talk about desalination, the use of green hydrogen technologies in order to reduce the carbon footprint, to reduce the industrial cost of desalination. So I was saying, I'm always being very, very careful. I always have paid a great attention to the contribution that young generation can bring, because in my organization, people think they can be president when they retire from work. Actually, I was a candidate in the full of my career, in the middle of my career, because I think that, again, coming to the contribution of young people, I think that you have to give your best when you are at your best. That's the time, not when you're retiring and you want to be just ending your career like in a beautiful shape. I think that it is very important to work, to strive for, also in my case for international organization, when you are fully operative, and of course there's another flip coin to this aspect. How can you expect to attract young generation if you are 70 plus years old? I mean, this is a problem, I guess. So I'm 20 years less, so something around that. So I think this is very important. And the second pillar, I decided I won't be leaving my mark as president of ASIAD at the end of my term, was the involvement of women. I strongly believe that it's not about gender. It's not. I don't like to think that these aspects have to deal with gender balance. There's no gender balance because in many cases, allow me to say, women are much better than men. So there is no balance to carry on, and it's just about giving women or girls the same opportunities and the same chances of working and, doing what they know how to do as men and as boys. So this is the second pillar that I've been trying to, and I was elected very successfully. So that's why, for both reasons, for three reasons actually, I'm very happy to be here. And I'm looking forward to have a very fruitful conference, because I hope that this sixth regional African conference also can be somehow a cornerstone. We need to gather, look, Africa, I believe, I've been in all the continents now, as a vice president, as a president, as a reference of FAO, United Nations. You know, many of you maybe know that I am also, on behalf of ICRD, I am permanent representative to FAO, to IFAD, and to United Nations. So I've been all over the places. But I believe that the continent and the country and the people that have the highest possibility of creating conditions for social, rural, favorable conditions is Africa. And there's the highest potential. So that's why this is the last reason. I'm very happy to be here, and I really, really hope that this conference will leave a mark and we will be able all together to cooperate with other countries. And that's why I'm asking you, all of you. You have to be promoters in order to have cooperation, to have collaboration, knowledge sharing, exchange of information, capacity building. I think this is essential, and it is most essential for a continent like Africa, for a country like Nigeria, and for you all. Thank you.
Gracias. Thank you very much. Welcome. Carry on, sir.
Okay, so now we've chosen to go with supervised learning and classification to do our mapping. So let's see. Is it working? Okay, so as you can see under supervised learning here and classification, we have different machine learning algorithms that we can use. Logistic regression, decision trees, random forest, gradient boosting, nearest neighbor, super vector machines, right? But in our case, because I'm not going to explain this in detail, so I won't ask you to choose. We are just going to choose one and we go with that. And this is one of the most used machine learning algorithms, which is called random forest. So we are going to use that one for the suitability mapping. And random forest is a machine learning algorithm that uses an ensemble of decision trees to make predictions. Like if you take the image here on the right-hand side, if you have, for instance, a bucket full of fruit, and then you want to determine for each instance when you pick a fruit within that bucket, what will it be? Will it be an apple? Will it be banana? Then you ask the model to predict that. So what the model will then do here, the random forest, it will build different trees to make the prediction. And the trees are developed taking a subset of the data. So every time each tree will take a subset of the data that you provide to it to build the tree and make the prediction, right? Then the outcome of the prediction will be based on the outputs on the result that different trees will be giving. For instance, if you take tree number 1, then it will do the classification, and this will result in apple. Tree number 2 is also giving apple, and the tree number 3 or number n is giving banana. But then it has to make a final decision, and that final decision, when it's classification, will be based on the majority voting. Like right now we voted, right, and choose between supervised learning and reinforcement learning. So the random forest algorithm therefore uses an approach that is called wisdom of crowds, which is based on the collective decision of multiple models. And the algorithm also builds multiple decision trees, each trained on a random subset, I've already said that, and considering a random subset of the features as well. And then by combining the prediction of multiple decision trees, then the random forest can improve the model accuracy, reduce also what we call overfitting, and also provide more stable predictions than a single decision tree. So for land suitability mapping, this is the general framework that we adopt. So we start by identifying the vegetable that we want to map. In our case here, we discussed, and then we took the example of tomato. Now we will have to go on the ground and take the coordinates of the locations where tomato is actually being produced. Once we have those coordinates, then we come and look at the data set that is available from the geospatial database, from the remote sensing perspective, right? And then we mention some of these factors that determine land suitability, like climate, soil quality, topography, water availability, and even some of the socioeconomic factors. Then we look, and globally, there are some of these data sets that you can find, right? You can find maps of water availability, you can find topography, rainfall, temperatures. Those are maps that you can find online. But sometimes the resolution of those data are very coarse, so which also limits the precision and the accuracy. So if you have national data sets, it's better to go with that one. And then we choose our machine learning model here, which is the random forest in our case, and we decide to build the model with 500 trees. So the model will develop 500 trees based on different subsets of the initial data set that we provide as input to develop the model, and then we do 10 iterations of that. And then the data that we collect on the ground, we want to use part of that data to train the model, and the other part to test the model, to assess the accuracy on our model on unseen conditions. And then we can calculate the model performance and generate the suitability map. So in terms of field data collection, in this project that we are doing, we've been collecting vegetable location points in different countries. We started with Mali and Ethiopia, and now we are also doing it for Ghana. And for each of these countries, we went around and we collected locations where vegetable is being produced. First, knowing where vegetable is being produced, and also knowing what type of vegetable is being produced, and what are the water sources that are being used for vegetable production. For instance, in Ghana here, you can see the distribution of the different vegetable locations, which is about 6,000 vegetable farms that we visited across Ghana, right? And this is the distribution across the different regions in Ghana. And what this survey reveals is that the top 5 most cultivated vegetables in Ghana are pepper, tomato, okra, eggplants, and ademe. So you can also look at the distribution in terms of number of points that we are able to get on the ground. I'm not going to go in the detail of the water sources, but this is also giving you an indication of the water sources that the farmers are currently using to produce vegetable on the ground. Some information also on groundwater availability, and also on the irrigation technology that is being used. If it's hand pump, if it's electric pump, if it's solar pump, or also if it's fuel pump. So we can look at the different categories that are currently being used on the ground. We did the same exercise for Mali and Ethiopia. I'm not going to repeat so that we can save some time. And then now we have to choose the predictor variables, or what we call the features when it comes to machine learning model, or also the covariates. So here, these are the predictors that we could get from geospatial database. So we have information on groundwater, we have information on surface water, information on soil, very important. We want to know the pH, organic carbon content, soil texture. Someone mentioned soil drainage at some point. Salinity is also important. And we have climate, we have rainfall and temperature. In terms of topography, we are looking at the slope. In terms of socioeconomic factors, we are looking at population density to determine where are the major cities. And then we also want to know the distance to roads, to know the accessibility. Someone mentioned accessibility to the farm. Also the travel time to the major cities, distance to cell phone towers, which can be used as a proxy to determine the size of the city, for instance. But we also want to know what is the risk and vulnerability of the location when it comes to flood and drought as well, because those two elements can also affect the suitability of the location for crop production. So we also integrate those variables in our model. But one thing that is also important, because we don't want to develop the suitability map and recommend that the crop is produced in a location that where it's not supposed to be, for instance in protected area. So we have a constraint where we map out protected areas, so that when we develop the map, for instance, there is no indication that that location is suitable for crop production, because normally we are not supposed to be there and do any anthropogenic activities. So when we finish that, these are a bit technical, so I won't spend a lot of time, but we need to also assess the correlation among the different variables that we've chosen. So here, for instance, we have 24 predictor variables that were presented, and then we try to look at the correlation among the variables to discard the one that are highly correlated so that we can save in terms of computation time. This is for Ethiopia. We did the same for Mali as well. And then after doing the modeling, we can also ask the machine learning to tell us what were the most important variables in predicting land suitability for this region. So this is an example for Ghana. So looking at the different predictor variables that we have, for instance, we ask the model to tell us what are the most important variables for predicting land suitability in Ghana. And what we can see here, the top drivers are distance to road. Second is rainfall. Then we have distance to reservoir, distance to phone tower, and distance to rivers. And the lowest important, we have groundwater productivity, slope, drainage, groundwater storage, and also soil texture. Right? Do you have any comment on this? Do you have any comment on this? Are you noticing anything? For instance, among the top drivers, we have distance to road, many distances, and then rainfall. And some of the drivers that are not that important in terms of the prediction that we could discard even if we wanted, we have groundwater productivity, slope, soil drainage, groundwater storage, and soil texture. Any comment? Are you noticing any pattern in the top drivers, for instance? Because without having this information, if it was you, with your expert judgment, which variables were you going to choose to be the most important for predicting land suitability there in Ghana? Yes.
Soil texture. It will be top drivers because it will tell the water holding capacity of the soil and would also affect the crop growth. It will be one of the top driver, according to me, soil texture.
But then you are seeing that in the top drivers it is not there. But what you are noticing is that we have distance to road, distance to reservoir, distance to river. Rainfall is also part of it. Do you have any comment on this? Or anybody else? Yes.
I think it's important to note that they are focusing on rainfed agriculture than irrigated agriculture. And also, for the road, it seems that the road is important key factor in the development of the vegetable. If they cannot have access to their farm from their houses, they cannot produce anything. So what is important that is showing there is that the road is a key. That is the distance, which, if I understand very well, for the farmer to get to his farm, produce, and then take back to the final consumption. Maybe you want to sell it or consume it. The road plays a very important key. It plays a very important role there.
That's a good point. So what we are noticing here is that beyond the biophysical factors that can be important for vegetable production, for instance, rainfall, if you ask me, definitely, if you have a place where there is no rainfall, I don't think you can grow anything there. It will be very difficult, right? Because rainfall, you even need to have rainfall first to get your recharge, at least to get the groundwater to be able to pump it later on if you want. So rainfall, that one is key. But then, this is meaning that your area can be suitable in terms of biophysical parameters. If you look at the biophysical parameters, you can have a place with good soil quality, and the nutrients, everything is there, but the farmer might decide not to go there to do vegetable production. Why? Because maybe the location is far from roads. So if the farm is located there, by the time they harvest and get access to the market, for instance, is going to be very long. So this place will not be a suitable place for that farmers. So this is what we can learn from here, that not only the biophysical factors are important, but you also need to take into account the socioeconomic factors. That's fine, all right. Okay, so this is just, here we have an example of land suitability map for vegetable production here in Ghana. So in the legend you can see the different categories. So this is giving you the probability of the land to be suitable for vegetable production. Then when it's less than 10%, we classify that as unsuitable land for vegetable production. When it's between 10 and 20%, we say that it's less suitable. When it's between 20 and 40%, we say that it's marginally suitable. 40 to 50%, moderately suitable. 50% and 70%, we say that it's reasonably suitable. And when it's higher than 70%, we say that it's highly suitable. And as you can see, we mask out location of water bodies because you cannot grow vegetable there. That one is classified separately. We also mask out the protected areas so that we cannot recommend anybody to go and produce vegetables there. So we have similar maps for Ethiopia and Mali because the project that implemented this work is starting in Ethiopia and Mali. And we have the same information. You can also see the share of the land in terms of area for each of these categories. For instance, in Ethiopia, we have less than 1% of the land that is highly suitable, about 47 in the reasonably suitable class, 29% that is moderately suitable, and also less than 1% that is marginally suitable. So first, when you generate the map, you get the probability map here, the A, right? And in that map, you can see the probability of the land suitability going from 0.12, which is 12%, up to 0.85, which is 95% of the land being suitable. So this is telling you where you might potentially grow vegetables in Ethiopia, right? And you can decide to reclassify this map to know if the land is suitable or not by putting a threshold. Maybe you can say, okay, above 60%, we consider that the land is suitable. And then you can generate the map B on the right-hand side, where you only have information if it's suitable or not suitable. Or you can do multiple classes, the map down here in the middle, where you look at several classes as previously shown. So the table here is just giving us the performance of the model. We have what we call the area under curve, the AUC ROC criterion or metric. Sorry. That varies from 0 to 1, and 1 being the best performance. And you can see that for Ethiopia here for vegetable, the model performed quite well because we have 0.95 for the training set and about 0.83 for the testing set. And then for each of the top 5 cultivated vegetables in Ethiopia, we could generate a similar map where you can also see the model performance, right? And we have the same information for Mali, so I'm not going to repeat this, but just to show you the result for Mali as well. And then after that, we might also want to know, okay, you say that the land is suitable for vegetable, but which vegetable is it suitable for, right? And then we have that classification as well. So we take, for instance, the first map here, the first most suitable vegetable. If you look at it, maybe I can let someone comment on this. We would like to comment on this and tell us what we are seeing. It seems like you want to say something.
Thank you. The first most suitable map we have on the left side shows that the land there is more suitable for pepper and onions. If I'm correct, pepper and onions, the few of potatoes, and a few of cabbage. So you could say that tomato did not, so definitely that first area is not suitable for tomatoes at all. So that's what I could see there. Thank you.
Okay. Any other comments? For instance, when I take the first map, first most suitable, we see that we have pepper and onion. But then where it is yellow, and we see that the model is suggesting that pepper is the most suitable. But maybe locally, the people don't use pepper there, or they don't like pepper. Then what could be the other option for them? if they don't like paper, the model is suggesting paper, but they don't like that one. What could they grow? What could they grow? Why onion? Is onion suitable there? No, as a second choice. If they cannot grow, they don't like paper. What should be the second choice? Sorry? Okay, some people are saying onion, some people are saying potato. Who is for onion? Who is for onion? Only 2 people? And now we have, okay, 2 people. Who is for potato? Okay, this is weird because we have 2 people for onion, 3 people for potato. What about the others? Onions. You want to comment? Yeah. Please give him the mic.
All right, good morning, everyone. I'm Nawihenu Echigil. If you look at the diagram there, you see that with the landmark and land space, pepper is more larger there. Then followed by onion. That means if they don't like pepper, then they go with onion. Thank you. Yes.
Okay, come. So this is the map. If we had to produce only one map,
yeah,
to tell people what to grow, it will be this one. So we'll tell them in this location here, where I'm putting my finger right now.
Yes.
What do they have to grow?
Pepper.
Okay. Now, the farmer there is telling me, no, they don't produce pepper there. So what can they produce? Here. If I say here.
Okay, that particular place. Then potato.
Then potato, why?
Yes. Because since it's this particular place that they have a provision for pepper, they want to still grow the same thing. Then we go with potato because in that place you can see some little particle of potato being planted in that area. That means if potato can be planted there, they can still grow very well.
Okay, let me re-explain this again. Because, do you know what these boundaries are? These are administrative boundaries. I'm not very familiar with Nigeria, but after the country level, what is coming? Is it region or department here in Nigeria? State. What's coming after state?
Local government.
Sorry?
Local government.
Local government. Under that?
Community.
Community. Yeah. Okay. Community or district?
Ward. Ward, then we go to the district.
Okay, wards.
Okay.
And you go within this word. Give me a name of the word in Nigeria.
A word in Nigeria. What?
Simple one and that I can simply pronounce.
Okay, for instance, Carward.
Carlo.
Yeah.
No. Cano.
Yes.
Carnu.
Yes.
Okay, I will try. So let's say here we have Carnuwad.
What? Yeah.
No, they don't like paper. So what will you suggest to them?
It's too strong.
It's strong.
Yeah.
It's not strong. It's just if they cannot grow paper, what should they grow?
I still go with that potato. They still grow potato there.
Why will you go with potato?
If they can't grow pepper, right?
Look at where my finger is. I'm here.
Okay.
Go put your finger on the same location on the map, on the second map. Okay, what do you have there?
Garbage.
So if they cannot grow paper, what should they grow?
Garbage.
Exactly. So we do the same thing. Then if they say, okay, cabbage also is not
Thank
part
you.
of the culture, they cannot grow it. What should they grow? Potato. Excellent. So now you've become experts in suitability, vegetable suitability mapping. Okay. We just have the same thing for Mali with a different pattern. I'll skip that one. And then here, so all what we've presented, we've embedded this in a tool, right? That is available online. Everybody can go and play with it. So if you just go, if you have data of specific location where vegetable is being produced on the ground, you can put that data and generate the suitability map for your location. But if you don't have any ground data, we also give you the possibility, based on the models that we've developed for the other countries, to do a first guess, right? And here on the right-hand side, we have the vegetable maps of different countries. And I want you to guess which countries they are. So the first one here, which country is this? Which country is this one? If you know Africa. Sorry? Which country is this? If you know Africa? Malawi. Okay, we have Malawi, we have Ethiopia. Another choice? Nigeria is not there? Nigeria is not there. Okay. Which country is this? It looks like France, no? The map looks a bit like the map of France, no? No, but it's not France. This is Kenya. This is Kenya. What is this one? What is this country? Yeah, this is Egypt. Which country is this? No, this is Zambia. Which country is this? No, this is somewhere in West Africa. This is Senegal. Which country is this? South Africa. Yes. So with this tool, you can select different countries. I can give you the link. You can go and choose Nigeria and see what it looks like. Right? So I told you that we have 3 steps in our approach. The first step was the suitability mapping. So we've covered that. We finished with that one. So now, for any given region, we can know where the land is suitable for vegetable production. But now we need to understand if the water availability is enough for supporting vegetable production. Then we do that in the sustainable water limits, because we want to use the water resources, but we also want to use it in a sustainable manner, not to use more than what is available. All right? So how can we support sustainable expansion of farm-led irrigation development? Right? So here we have this sustainability framework for vegetable irrigation approach that we are developing. And the main aim here is to only use renewable water resources. And then secondly, to maintain the water use within the limits of water availability. We don't want to use more than what is available. And third, we also want to avoid over abstraction. So in our institute, IMI, we develop different water data products. And one of them is the surface water resources with water that is available in rivers and also water bodies. So we use those data at the monthly level for surface water limit estimation. And when it comes to groundwater, we also want to now understand what is the renewable groundwater resources available or utilizable groundwater. And we calculate that by taking the difference between the groundwater recharge potential and then the current groundwater use, which is determined just as a proxy of blue ET. I guess you know blue ET, right? Evapotranspiration, when you split it to get green ET and also blue ET. So after that, we have then seasonal assessment of the sustainability framework by using different data: precipitation, evapotranspiration, blue and green ET, runoff and discharge data, groundwater data, utilizable groundwater potential, and also irrigated and rain-fed maps to demarcate between the locations that are under rain-fed condition and the locations that are also under irrigated condition. So in the map here on the right-hand side, we do some seasonal analysis. So we first look at surface water precipitation availability or precipitation amounts, and then we compare that with different crop water requirement categories: low crop water requirement, medium crop water requirement, and high crop water requirement. So when precipitation, the amount of the seasonal precipitation is more than the crop water requirement, then you can just do rain-fed agriculture, if you want, because precipitation is large enough to cover the crop water requirements. But in the case that precipitation is not enough, so the difference for irrigation water requirements, we then go and assess surface water requirements in the second block, where we look at the base flow index, we also look at the distance to surface water, the river discharge, and then we come up with an estimation of surface water availability. And when the surface water available is more than the irrigation water requirements, then you can use surface water to do irrigation, right, to complement the deficits that the rainfall cannot cover. But then in case surface water also is not enough, then we assess utilizable groundwater, and then the deficit for irrigation water requirement is then covered by utilizable groundwater that is there. So these are some maps of water limits for Ethiopia, looking at different seasons in Ethiopia. On the top you have the surface water limits, and on the bottom line you have the groundwater limits. Right? This is just an example for Ethiopia for different seasons, so you can see the patterns across different seasons. And here we just overlay our suitability map. So when we know that where the area is suitable, then we want to know if we have to use surface water or groundwater. So the dots or the circles in green represent surface water, and then in yellow we have groundwater. So for each administrative boundary, then you know if you have to use groundwater or if you have to use surface water for your vegetable production, depending on different crop water requirement. Either you are below 400 millimeter or you are above 400 millimeter, and then 800 millimeter. So now we can move to the third step of our approach, which is the technology suitability selection. So once you know where your land is suitable, which water source to use, if it's surface water or groundwater, then you want to know which kind of pump, for instance, you can use for mobilizing your water resources. So how do we determine suitable technologies for irrigation? So here we adopt a multi-criteria approach, and we look at different factors also here. So we have groundwater depth, we have solar radiation, we have distance to grids, electricity grid, we have travel time to fuel station, and travel time to population with different sizes, 50,000, 10,000, and 5,000. And then in the middle part, then we can do different combinations of those factors by putting different thresholds. For instance, in the first one, we have groundwater depth below 25 meter, and a travel time from places where population exceeds 5,000. That should be less than 1 hour. Then there we will suggest manual irrigation. Then in the second category, we want to use solar pump, but we have two types of solar pumps here. The first type, you can go up to 7 meter depth for groundwater, and the second type, you can go up to 25 meters, right? And then for the first type, for instance, in blue, light blue, you can see that the groundwater depth should be less than 5 meters, so shallow groundwater, and solar radiation should be above 1,300 kilowatt-hour. And then the travel time from that place to a city with a population of about 50,000 people should be less than 5 hours. So this is put as a condition so that in case there is a part that is not working in the pump, then you can easily go to buy that part to come and replace. And that place should not be far from your place for more than 5 hours. Otherwise, you might not. It might not be an incentive for you to travel there to buy. So these are the different kind of combination we do for the other pump types as well. We have electric pumps and also fuel pumps. So we just put different criteria to determine which technology, irrigation technology we have to use. So now that we know all the three components of our approach, then I'm going to show you the tool that we've developed also that is online, that anybody can go and use, which is called the Vegetable Irrigation for Climate Resilience Toolkit. So this toolkit is online, and it looks like this. So when you land on the platform, then you can choose the country of interest. Right now we have data for Ethiopia and Mali. So you come here, you select in geographical area, then you choose that location. When you choose Ethiopia, you will have the map of Ethiopia. The second filter is about the seasons. In Ethiopia, we have 3 seasons, 2 wet seasons, and then 1 dry season. You choose the season of interest. Then for crop water requirement, depending on the crop that you are looking at, you can choose if it's low crop water requirement, medium crop water requirement, or high crop water requirement. You select that. Then we give you also the option to choose your water source. If you want to irrigate with surface water or groundwater or a combination of both. You make that selection, and then you also select the distance to the water source or the depth to the water source. If it's surface water, we have different categories and different distances to the surface water. If it's groundwater, we also have different depths to that groundwater. You select that, and then if you have a specific pump type that you want to use, you can also select it. Otherwise, you can select all pump types, and it will generate a map like this, which is telling you in Ethiopia, for instance, the proportion of the land that is suitable for each woreda. In Ethiopia, we call it weredas. This is administrative level number 3. If you go from country level 0, you go down. This is the 3rd level in Ethiopia, and it's called wereda. Then for each wereda, we can tell you how many hectares of land you can potentially cultivate with vegetables. And then on the right-hand panel here, you have the name of the wereda, the season that you've chosen, the period of the season, going here from June to September, the total area of the wereda, and the area that is potentially suitable for vegetable production in that given wereda. The name of the wereda here that we've chosen is Bear. And then we give you information on the maximum irrigable land using surface water, and the maximum also using groundwater. In this case, groundwater does not qualify. And for each of the irrigation technologies, going from manual to solar to electric and to fuel pumps, we can also recommend which of the technology is suitable for that specific location, and how much surface water you can use to cover the land area that is suitable for irrigation, for vegetable irrigation. Sorry. So I think the next is just a demo. Can you click on play there, or I don't know if I do next if it will come. Yeah, this is just a quick demo of how the tool works. Okay, so I have some questions for discussion, depending on the time that is remaining for us. So the first question is, how do you think about the relevance of this tool that has been presented? Will this tool be useful for Nigeria? Will it be interesting to have Nigeria there in this tool? Third question, what should be the priority crops for Nigeria when it comes to vegetables, for instance? Fourth question, what additional drivers will you consider for the suitability mapping in Nigeria? We discussed some of them. We presented the one that we've put in this tool. What will be the most critical for Nigeria? And what additional features will you add to the VIC tool, the Vegetable Irrigation for Climate Resilience Toolkit that we just presented? So we can come back to this. After this, I will just open the floor if you have questions. Then if there is not much question, we can go to these questions for additional discussions. So as you know, IMI is a partner of this ARKID conference from Monday. So we have a couple of events that will be happening, a couple of sessions. And I wanted to share with you some of the sessions that we will have in case you have any interest and you would like to come and join us. So the first one will be on Monday from 2 p.m., which will be on advances in Earth observation and digital innovation for transforming water management. And the second one, still on Monday from 3:30, which will be on irrigation and water management, key enabler of value chain technologies in Africa's agricultural transformation. And the third one, which will be on Tuesday at 9 a.m., which is on shared farmer-led irrigation development vision and scaling pathways in sub-Saharan Africa. Then we continue with still Tuesday at 11:30. We have another session on thinking beyond water with a nexus perspective for transitioning to sustainable agri-food system for the Africa we want. And then we have this water talk that we have. So this is a seminar series that we started last year in partnership with ECOWAS that we run twice a year. We had the first session, and the second session was on AI and machine learning for water resources management. And this third session will happen here at the ARKID conference. It's going to be on Tuesday at 2:30 p.m. on the topic of rethinking irrigation for resilience in West Africa. So you are all welcome to come and contribute with your ideas. So I think that's all for me. This work is done as part of a team. Of course, I'm presenting today, but there are many other people. Naga, Mansour, Dashana, Angie, and also Petra are all part of this work that has been presented. So now I would like to thank you for your attention, and if you have questions, I'm happy to take them. Thank you.
Thank you very much. Round of applause for him, please. Is there any questions? Any further questions, please? No questions? Okay. Yes. Thank you very much, sir.
Thank you very much. Okay.
Thank you for a wonderful presentation, sir. My question goes like this. How can artificial intelligence and machine learning using smart irrigation involvement address emerging issues such as climate and water scarcity? Yes, okay. My question is, I'm saying, how can artificial intelligence and machine learning using smart irrigation involvement addresses emerging issues such as the climate change and the water scarcity?
Thank you. That's a very important question. Of course, what we presented today in the framework of this forum was mainly to look at the potential of machine learning for suitability mapping to support irrigation recommendation on where you have to do vegetable production. But the application of machine learning goes beyond that, and in many, many fields. For instance, if you take Google, they have a good model that they use to do flood forecasting, for instance, globally. Right, that's what that's one of the key thing that machine learning can do. You have flood forecasting. You can also do drought monitoring and drought forecasting. Then in terms of climate change as well, we also have applications there. So there are many, many applications that you can do with machine learning beyond what has been presented here. So if you want, we can discuss further. I can give you links to some platforms or resources that you can potentially explore.
Thank you very much.
All right, yeah.
Round of applause. Okay, we still have questions? One more question.
My question is, can machine learning address some issues like leak detection in the irrigation systems when there's a problem or anomaly in the functioning of the networks or system? Can it also address issues as such?
Yeah, it's possible because, for instance, among the technologies I presented for artificial intelligence, for instance, you can see that the reinforcement learning is mainly about developing robots, for instance. And in that case, reinforcement learning, for instance, can be used to see in the system where, for instance, you have some leakages and then potentially address them. So that's also possible. Yeah, and people are doing that. I think I was getting a presentation last year in November from a company in Taiwan where they have developed technologies to detect leakages in water distribution systems. Yeah.
Oh, thank you very much. Please, any further questions can be asked later. Maybe you can read him. Let's save time, please.
Yeah,
Thank
or
you very
during
much.
the
Round
break.
of
Thank you
applause
very
for
much. Thank
Dr.
you.
Mokhtar. Thank you very much. We appreciate you, sir. Thank you. Please, we'll be having a photograph, a group photograph with the ICID president, if you don't mind, sir. I would love to have a group photograph, please. And as we are at it, please let's recognize our senior citizen, our irrigation father, like our director always says. Please, everybody, round of applause for Engineer R.A.K. Jimo. Please, he's here with us here. Thank you very much for gracing this occasion. Thank you. Please, everybody, please let's have a group photograph with him. And when we are done, we'll have our tea break outside. Thank you very much. Please, let's settle down for the next class. Thank you. The next class will be on remote sensing for irrigation performance, hands-on on practical, part 2. We did the part 1 yesterday. So it was concurrently one with the other one. So he will explain himself very well. So the presenter is Dr. M.M. Manuel from BUK, Minor from BUK, Nigeria. Please, a round of applause for him.
Thank you, thank you. You are seeing my face for the second time, for those who witnessed my presentation yesterday. I was introduced to present a hands-on practical. I think that was overrun by yesterday's presentation because the presentations actually, I asked the organizers whether we were going to have a really hands-on, but unfortunately, I think the setup wasn't there for any hands-on or remote sensing. So I think what we would do is to give the basics of remote sensing and to discuss more. However,
Sorry, sir. Permit me to welcome our senior citizen. My apologies, please. Please, round of applause for Dr. E.A. Aderibibe. He's here in our midst today. Thank you very much. You can go ahead, sir. Thanks.
All right, thank you.
Oh, sorry. My
One more.
apologies. Our prof is also in our midst, Professor Igbadu Henry. Thank you very much.
You're welcome.
Thank you very much, sir.
All right. Thank you very much. You're welcome, sirs. Just like I was saying, this presentation is supposed to be more of practicals. We're supposed to fly drones, acquire information or data, use some software to analyze the data and get results, right? That could have been perfect for hands-on, real hands-on. As we rightly said yesterday, that this training for youth or young professionals in irrigation and drainage, we are looking at tomorrow. So it is not about today, but tomorrow. So we're building a young professionals who will be farming using technologies. All right? And remote sensing is one of them. I think remote sensing has been identified as one of the emerging technologies, remote sensing GIS, aside nanotechnology, biotechnology, and maybe AI. So remote sensing is very versatile. It has a wide range of application. In irrigation and drainage, it has a very good application. Right now, many people are using remote sensing in addressing many problems related to irrigation and drainage. Yep. Okay. So remote sensing, or the application of remote sensing and irrigation assessment or performance assessment is very, very important. So when we talk about irrigation performance assessment to evaluate effectiveness and efficiency of irrigation systems, it involves what? Analyzing various factors such as how well the system delivers water to the crop, manages water resources, and impact the environment. So when we say irrigation, it plays a crucial role actually, especially in semi-arid regions. Efficient irrigation management is necessary to optimize water use and improve crop yield. However, applying technologies such as remote sensing have emerged as a powerful tool for assessing irrigation performance by providing spatial and temporal data on vegetation health, soil moisture, and evapotranspiration. These terminologies, we keep repeating them over and over. However, they are not new, but what is new is the application of the technologies, remote sensing, AI, and Internet of the Things, so on and so forth. So this is the way. Now, before we go deep or go to the real thing of assessment of irrigation performance, let's have a basic understanding of what remote sensing is all about. Okay? Actually, this is where we need to do some hands-on so that you can get a real touch with the data and information. How do you drive? How do you come up with a result that can be useful in addressing irrigation challenges? Now, remote sensing is a process of gathering information about the Earth's surface without direct physical contact. This is just very general. Nowadays, we use different method or different mode of remote sensing, like using drones to acquire information. Drones are already being used in addressing issues related to irrigation. And it relies on a sensor mounted on the drones or satellite imagery or aircraft drones to collect data, which is then analyzed in various applications such as agriculture, forestry, climate monitoring, and urban planning. But the most important thing is, especially with regard to irrigation assessment, drones carries a sensor which acquire the image that can be processed and then applied to address issues related to irrigation. Now, by way of introducing just basic principles of remote sensing, remote sensing actually is using energy source from the sun. Okay, the energy source is needed for detection. It interacts with the Earth's surface to enable absorbed, transmitted, and reflected depending on the material. Sensors on board, devices that capture energy and convert it into images or data that we use. And then finally we process. The data is being processed and analyzed, which interpretation of these images to extract meaningful information. This is basically the startup. And like we said, the remote sensing, energy for the remote sensing all comes from the sun. It hits the target, which is the surface. If you have a farm, a paddy field, meaning that the rice field could be the target. And then when the energy comes and hits the target, it reflects back to the satellite. So there are different type of sensors. We are going to talk about that, the active and the passive sensors. So when the sensor absorbs the information, it's being transmitted to the ground station, which receives those information for processing. After it's being analyzed and processed, then it can be used. Now, where does this information come from? I just give this to give a fair understanding of how does the remote sensing or the satellites, the sensors acquire those information. You are all aware of this electromagnetic wave. This is a wave through which the image is being classified based on the different radiations. We have the X-rays, the ultraviolet, the visible light. The visible light, this is where mostly the sensors like the visible imagery use. For example, the drones, they use the visible radiation to acquire the information. There's also infrared, microwave, and shortwave for different uses. But for remote sensing, mostly for irrigation farms, we use the visible light, which is the RBGG, okay, which acquire the visible image based on the picture of the image, and then those pictures have been analyzed to know if it is for plants, to know the health condition or the soils or the water stress or any disease stress on the plant using this visible light. And the infrared, this is where from the image we can analyze like the NDVI. The NDVI, from NDVI we can determine whether the plant is healthy or it has any disease infection. And also it can also determine the nitrogen contents of your plant or of your leaf. So these are very important. However, just for your information as an introductory aspect for you to know that this is what the remote sense data contains. Now we have two types of remote sensing. We have passive remote sensing and active remote sensing. The passive remote sensing uses natural light on Earth emitted radiation, e.g. optical, infrared, thermal sensors. Examples include the Landsat and Sentinel satellites. While the active remote sensing uses artificial sources like radar or LiDAR to send signal and capture the reflection. Examples include the static aperture radar and LiDAR mapping. So the difference between the two is that the passive remote sensing uses the sunlight energy, while the active ones, they emit the energy to acquire the data and then take back the information for process. While for the passive ones, they uses the sunlight, especially the Landsat, okay? The Landsat images and other satellite images like the Sentinel and everything. So they uses this passive, is under passive remote sensing. While the active remote sensing, such as LiDAR or radar, synthetic aperture radar, these are different sensors with different application. But so remote sensing platforms, satellite-based. We have the large-scale long-term monitoring, especially the Landsat, which are very free online, or you can obtain them from different platforms like USGS, Earth Explorer. We have MODIS, Sentinel. All are some are free, some are not, but depending on the spatial resolution. For example, the Landsat is free, actually, absolutely. Has a spatial resolution of about 30 meters. So if you're looking for very high accuracy data, you may not, free Landsat may not be an option. You need to go for a very high resolution satellite. Then there's the airborne, which you can use your drone to collect the data yourself. Actually, at the beginning, I was thinking the practical will take place. So I even asked whether we can bring drones and fly the drones so that we can get the data and process as part, just for you to have a hands-on training on flying drones and collecting imagery. Because for the drone, you have a very high resolution imagery with a high spatial resolution of 0 something or 0.1, 0.4% meter. But for Landsat, like I said, 30 meter, especially the panchromatic, you go 15 meter. If you are going for thermal radiation, the spatial resolution up to 100 meter. So it's very coarse. So the ground base, which is used for calibration and validating the data. Now, where do we apply all this information? When we get the satellite data or from UAV or from satellite base, all this data are being processed. For what? Applying in agriculture, forestry, water resource, climate studies, urban planning. But our interest is for the agriculture. For agriculture, we'll apply this information for crop health monitoring, irrigation assessment, soil moisture estimation. This is basically the most important aspect of application of this. So we now look at the satellite-based remote sensing. I'm bringing this so that at the end you may want to download the satellite data for your work. So the Landsat, which is from NASA or USGS, it provides thermal, optical, infrared data useful for monitoring vegetation like the NDVI and surface temperature, land surface temperature, okay? But for the Sentinel, yes, this offers high resolution also multispectral data to assess crop health and water stress. So also for the MODIS is also by NASA, just like Landsat series. It delivers near daily imagery for large-scale monitoring of land, surface temperature, and vegetation dynamics. So MODIS has it has near daily imagery, meaning that the temporal resolution is very good. While NASA has a temporal resolution about 16 days, which is 2 weeks. So if, for example, you want to use, you want to monitor irrigation schedule, maybe water stress for irrigation, chances are that if your irrigation schedule is below 16 days, meaning that the Landsat data may not be useful for you, because if it is 5 days you want to obtain imagery, you have to, if you are using Landsat, you have to go for 2 weeks waiting for the imagery before the satellite return to your farmland to take another image. So this is actually, you can take, that is why application of your UAV drones, comes in, because with your drone, at any time you can send your drone to obtain information and process to get information to address an issue. Okay, so this is that. Now, for the drone, drone was used to be equipped with multispectral thermal sensors. UAVs provide high-resolution imagery for localized irrigation system, useful for detecting irrigation uniformity issues, leakages, and crop stress at farm level. So that's the use of drones. Network based on Internet of the Thing are increasingly being used in agriculture sector to meet challenges of harvesting meaningful and actionable information from the big data generated by these systems. Information is power. Once you have things that you can get information that will help in taking decision in addressing some problems. So among the sensors that take those information, when we say the sensors, even your phone camera is a sensor, right? I just want to bring it so that you understand, and the same type, but they have different type, even in our phones we have sensor of different capacity, high resolution sensors, some are not, the megapixel, determines the quality of the image it will take. So also on the platforms like satellite, they have also different type of sensors, but all it acquire imagery with the same pattern, because like our phones, the sensors is passive sensors, right? It uses the light. Okay? In a clear dark, it won't take any image except if there's light. So it's passive sensors. Okay? Except the active ones, which, for example, some CCTV, even in dark, it still take image because of So sensors are different, but the passive ones, example I've given, like the Landsat TM advanced very high resolutions, the Spot, the MODIS, the Econos, the Kickbats, these are different, satellite with different sensors in space. Okay? The passive sensors is for air photography, while the active sensors are radar and DEMs. We all know DEMs, we'll be using it in analyzing hydrological analysis and so on and so forth. This sensors, okay, I think we are done with this. This is our website for the USGS website. Part of the practical, which we couldn't do, is to introduce you to this website. It's very important. We have a lot of information that are accessible, free, some are free, that we can use for our daily irrigation assessment. Okay? In this, if you just open an account with the website by logging in, and then you will get access to this imagery. There are various types of images. The DEM are there, STRM are there, Landsat image, Landsat 1, 2, all the Landsat series. And currently, Landsat 8 and 9 are running. Okay? You can even get recent data with Landsat 8 and 9. Pardon? USGS App Explorer. If you search in Google, you will see the website. So you can log in. If you log in, there are such criteria which you can use to check and set up your boundary for which data you want, which scene you want to obtain. Okay, that correspond to your location where you want. Okay, but normally it depends where your projects are. May not be covered by one scene, but you can download multiple scenes and then apply the techniques of GIS remote sensing and then process the data. You can, make a composite of all the bands. You can mosaic the data into a single image and then process it, to get a meaningful information from it. Okay. The remote sensing software in use, so far we have quite a number of them. The QGIS, some are free, some are not. Okay. The QGIS, the SagaGIS, the ArcGIS Pro, ArcMap, ERDAS, Imagine. ERDAS is for remote sensing, Orfeo Toolbox, and Trimble Cognition. Other notable options include ILWIS. ILWIS is free, Google Earth, ENVI, PCI Geomatica, Global Mapper. These are all software that you can pick one. It's not difficult to learn. You can learn some of them and be using it, both for the remote sensing and GIS, except all the ArcGIS or Esri products normally are not free. They can be freeware, but not free complete. You can use it just for test and later you need to buy. But they are actually very, very robust. This is an interface for ArcGIS Pro. I just downloaded this yesterday after this. I just downloaded this scene. It's an example and package them, composite. And then from there you can do a lot of processes. You can do, with this image, you can see the NDVI is NDVI colorized. You can conduct a lot of analysis. And it's a very powerful software. This is ArcGIS Pro. Okay, so you can also subset your area, the map, the location, or even your farm out of this, if this is correspond to the area you're working on. Now, for the other images, apart from the visible, there's also a thermal imaging, band 9, thermal imaging, band 10 and 11, I think. Okay, which identify temperature variation related to soil moisture and water stress. So all the bands, you need to understand, in remote sensing, basically, if you want to go into that, you need to take more courses on remote sensing to understand the basic principles, understand how the digital numbers work, how the pixels, which is the unit for the image, and so on and so forth, so that you can manipulate the data. And then you know all the bands, for all the images that you can so that, for example, you are talking of visible images, band 1, 2, 3, okay, near infrared, band 4, 5, up to 7, thermal infrared, band 9 to 11, panchromatic, band 8. So all these have different approach and different work it does. And then the hyperspectral sensors, these are subtle variation in crop health,
which can indicate over or under irrigation. Hyperspectral actually is a bundle of bands. It's a high resolution image, which we use to identify. For example, if you want to do classification for different plants, you have a big farm, you want to identify which crop are being planted, which, to segregate between crops and weeds, okay, based on their leaf pattern and everything. So you need high resolution bands like the hyperspectral image. Okay, the soil moisture, which we use are passive microwaves like SMAP, AMS-A. This measures soil moisture at different scale. The SAR synthetic aperture radar sensors, for example, the Sentinel-1 data, provide all-weather soil moisture estimation for precision agriculture. So these are host areas you can explore to get. Some you can even get a process data that is already packaged for you to use. Okay, so now this talk is about remote sensing and key performance indicators or performance assessment of irrigation. So let's talk about the performance assessment of irrigation. The key performance are the crop water stress index, derived from thermal imaging indicating plant weather stress. Like I said, you can use band 10 to 11 for thermal processing. And using the thermal processing, because thermal processing is an image that shows the temperature, okay? That shows the temperature and heat. So it can be used to process, to indicate where there's a plant stress due to moisture, okay, due to lack of water. Evapotranspiration mapping, estimated using surface energy balance algorithm for land, such as Sable and metric code models, okay? There are also water use efficiency, which assesses how effectively irrigation water translated into crop biomass, okay? So you have the water application. Now you can use remote sensing to, estimate the biomass of the field, okay? Irrigation uniformity and coverage evaluate using NDVI and soil moisture data. The NDVI, maybe we'll talk a little on that later, but it's very important aspect we use in soil moisture data. Now, this is just to give you understanding on how you can monitor your field throughout the cropping season. You can take a weekly data if you want. This is a data taken on weekly basis. Weekly image of paddy field 10 by 10 meter, which data and method we use multispectral images of various Earth observation satellites, and UAV can be used. NDVI, green NDVI, GNDVI, and TGI. These are various indices that you can process using the Sentinel or Open Access Hub or UAV. This, you can use open source remote sensing or GIS software, Sentinel-2 Bus, QGIS, or ArcGIS, to analyze all this. Like what I showed you in ArcGIS Pro, you can do the NDVI there. But look at this image, which shows the first one is week 1 and the last one is week 16. So you can see you take the image of the entire season for the rice production, from land preparation to harvest or to maturity, okay? So this gives you an idea. From this you can monitor your nitrogen level in the plant, okay? Which week has a good, where there's a sign of stress, So when do you apply your nitrogen, when and how much nitrogen to apply? All this decision can be taken when you have a good image of your land. When we talk of NDVI, because NDVI is a very powerful tool in assessing plant health, So how do we assess the NDVI? NDVI, actually, we use the near-infrared and red band, okay? The near-infrared and red band. Okay, band 2 is red, and near infrared is around band 4. Okay, 4. So how do NDVI estimate it? NDVI is near infrared minus red, all over near infrared plus red. Okay? So normally if you have, for a healthy plant, the NDVI values goes, it ranges between 0 to 1. Okay? So the higher the NDVI, the better the crop health, right? The lower the NDVI signifies plants have an issue. And if the near infrared is higher, if the near red is higher with a low near infrared, that shows plant has an issue. Okay. While if you have a high near infrared and low, visible red, that indicates a healthy plant. You can see from the leaf. And an NDVI of 0.72 is okay, while 0.14 is not. Okay, so this is how to identify, and these are things you can do in your lab while seated in your office. You acquire the information, you process this, so before you go to the field, you already have a lot of information about the field. This is for water, to monitor water storage. You can also use the remote sensing to monitor the water storage of a reservoir. You can take the information annually or seasonally. For example, in a year, there are 3 seasons of cropping using the reservoir. So you can take the image of the reservoir after every season. Now, that can give you an idea of the image, how the reservoir is shrinking. The water body reduces by the surface area. Okay, so that will give you an idea of how much water is being used in that season. And the data you will use, you also use multispectral satellite imagery, like the near infrared, the G-band, or the SAR imagery, day-night observation. You can use SAR, and then the data sources from Earth Explorer, just like what I showed you, USGS Earth Explorer, or maybe you can download it from Digital Globe Open. And then you use remote sensing GIS also to process this data. So this is a very good way of assessing the reservoir. Now you can also assess real crop pattern using the same imagery. So meaning that there are various approaches to use the satellite imagery in agricultural field. You can assess the cross pattern by identifying after assessing the pattern, by processing the different type of crops there, like paddy, chilies, cotton, tobacco, sugarcane, and so on and so forth. And then you have the pie chart presenting the area occupied by those crops. Okay, which crop has a highest? You can see the paddy has high in the first image. The second one, pulse and all, contain about nearly 60% or 55, 56%. So this is another approach that you can use the satellite image to process and understand the type of crops that are being planted in your area. So remote sensing data, like I said, these are different sources. You can get USGS first, then you have the ESA company Open Source Hub, you have the NASA App Data, Planet Hub. These are different websites you can obtain satellite data for your work. The online ready-to-use resources, you can use the Earth Observatory satellite, but mind you, this is not free, okay? But it's a very, very high-resolution satellite imagery here, well prepared, just ready to use. You don't need to apply your software to analyze. They've already analyzed some things, and they will supply to you the information you want. And with a very high resolution, a resolution of about 10 meter, for example, for crop classification solution in numbers. We can see based on when do you request, within 1 month, they can deliver it to you with a very precise design. So what is the challenges and future directions in this work? Data processing complexities, which require integration of multiple data sets, advanced modeling, and even some of the tools. You know, they are very, very, some are really very expensive. Others are complex. You know, so you need to train yourself very well to be able to apply the knowledge to come up with a result that will be useful. It's also, like I said, a very cost of high resolution data. Like in the EOS, you need to buy the data because it's not free. If you're using UAV or commercial satellites, also can be expensive. Weather dependency, cloud cover affects optical remote sensing method. For example, areas where there's always cloud cover, you know, for the visible images, it's a challenge because most of the times you are looking for an image for a particular area and all of a sudden there's a cloud cover. Even though in some software there's a way you can clear the cloud cover because there's what we call the atmospheric correction and radiometric corrections in order to get the data visible enough. Also integration with IoT, AI, we have been talking about this quite once. Dr. Dembele have talked a lot on AI for us today. So future advancement may combine remote sensing with IoT sensors and machine learning for real-time irrigation optimization. You know, yesterday's presentation we talked about resources are really getting scarce, and we got to apply technologies, you know, in order to optimize the use of those resources. They are also really getting expensive. Thank you very much for listening. So any question regarding the presentation? Yeah, I know some may be, is it something new to you? Yes, you want to say something? Okay, where's the mic, please?
My question is about accuracy in terms of the satellite data and let's say the satellite data compared to let's say drone, which you do it yourself, and the satellite data is as if you are acquiring the data from the, let's say, the cloud or the satellite which has been stored. So is there any discrepancy? Can you get some discrepancy, or it will give you the accurate, let's say, the precision of your data when you are trying to acquire it? We know sometimes even with our manual GPS, when we are taking some points, you find out that there's that discrepancy. It doesn't give you the actual, the accurate precision about the location you are trying to take. Do we experience some challenges in terms of accuracy?
That's right. Your question is noted. Actually, when you're talking about the satellite imagery, the two most important factors you need to take into consideration is the resolution, whether spatial or temporal resolution. This is the most important. So the use of drones have, because it's closer, okay, to the point area of acquisition, so it has a very high spatial resolution, okay, very high. While satellites, because satellite is in space, okay, and it's not easy, you know, satellite is taking the entire, for example, Landsat is taking the entire globe, the image of the entire world, okay? So it has to go around the globe, you know, very quickly, and in every 16 days it will come back. Before it come back, finish the rotation. 16 days, it took 16 days to complete the rotation. So that is why we employ the use of drones. For example, if you have a farmland, you have a farmland of less than 100 hectares, your drones can do that work in a very short period of time and with higher resolution. Okay? Because all you need is to process the data so you can take decision. Right? The resolution is what matters. In terms of accuracy, the satellite imagery, they have already given you their spatial resolution. You know it. So with that, when you have resolution of 30 meter, I can give you guarantee that you cannot, within 10 meter, it's difficult to segregate between an item. Okay? So it has to be a very bigger thing. You can see that single pixel, because the pixel is the unit of picture, right? So if you zoom the satellite to a pixel level, you will see that one pixel is 30 by 30. That is the size of a pixel. So it's coarse, actually. It's coarse. But there are, okay, thank you. But there are information that you can use. You don't need a very high resolution satellite to obtain those information. Okay? Yes. For example, if you are digitizing your canals, or field channels, drainages, a satellite imagery of 30 meter is okay. Can do that. Or you can still see, the image, because it's a line. It's a long line of a drainage system or a canal. Okay? Or you are looking at a dam. Mostly dam has a bigger surface area. So this is the, are you clear? All right. Any other question?
Yes, sir.
Okay.
Good afternoon, everyone. Is it afternoon already? Yeah. Mine is not directly a question, but just an observation. As we all seated here, I believe we are the drivers of this idea to the sink farmers on the field. And we don't have problem. Remote sensing is not a new thing, but its application is totally a new thing to me. Like the active remote sensing, which receives direct sunlight from its light from the sun ray. I will ask, doesn't it have a negative on the soil health? As already the idea of GMO in the society, people are having concerns about it. How it won't build up and add up to the already compound idea of GMOs to the public.
Okay, thank you very much. Before the advent of remote sensing, there has been sunlight. Sunlight is just to provide the energy that the sensor can use, to obtain image. Okay, because the image, when the rays hit the surface, it's being reflected based on the type of surface it hits. If it is a water body, it has different spectral signature. If it is a bare surface or plant or any object that reflected the light, okay? It is as a result of reflection that you are able to see, right? Lights reflected on the object that enters your retina, and then the image is formed. So also, that's how the sensors work. Your retina of the eye is just an example of a sensor. Okay, it's just to assist you to form the image. So it doesn't have any side effects because the light is already there. Only that the sensor is using the light to obtain the image. But it doesn't have any effect on the soil, just like you said. It has nothing to do with the soil.
It has nothing to do even with the object it's obtaining. It's just like if you say, if you look at an object and then you say, does your looking has effect on that object? Does it destroy the object? It's only form an image for you to see, to identify the object. Is it clear? Thank you very much. Yes, please, where's the mic? Hello? Who has the mic? Someone is raising hand there.
Thank you, sir. Sir, your presentation is okay, but I noticed the issue of drone. The drone that I saw it in your presentation. Yes. How do we apply it based with the security challenges we're having, specifically either in the farm or in the bush? And if we are really applying it, why the security is so tense all over the world, all over in the country? How will you respond to that? What is the solution and what is the way forward? Thank you.
All right. I know his concern is with the security. Right. There are different type of drones. We are not talking about the military drones. We are talking of agricultural drones. This is a simple drone. Well, it's being used even within cities. I think here maybe because of our predicament of security issue, maybe some people are so skeptical to use it, or maybe there may be some security threat because you don't know whether the drone, is it a safe one or not. However, for a farmer, drones are used, especially all these movie makers, the film makers, they are using drones. Event managers are using drones, right? So you can use drone for your farm. There's no problem with it. You are flying the drone over your farm. You are not flying the drone over somebody's house or for surveillance. Okay, you are flying the drone to obtain image for your farm, and then you bring down the drone until when you need it again. So I think the issue of security challenges, and besides, I think yesterday Prof was saying that these security challenges, it will fade off with time, right? Yes, everything has a time. One day you will not, future generation may not even know about all these things we are talking about. So that, because of this, we shouldn't say that we don't want to use modern technology, because here we are talking about the application of, remote sensing to agriculture. And it's being used. It's not now. It's not just, being used. It has been in use for quite some time. Okay? We have been using drone. I told you I wanted to bring a drone to fly just for you to see, but you are just like what you said, the security, blah, 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 that we have to seek clearance for the air before we can use it. So it's going to be a whole lot of process, So, but we can keep it for another time. The young professional can arrange. Honestly, this is just for discussion's sake. But for you to get a useful knowledge that you can apply, it's about that hands-on. You need to get in touch. You need to download the image, or you need to fly the drone and get the image down, know the type of image you obtain, analyze and process the image, and bring out a result that you can use for decision making. This is actually what we're supposed to do in this workshop. However, like I said, we are still around. You can organize another 1 week hands-on intensive remote sensing and data analysis, so that you can be a professional in the field. Okay? Right. Are you okay? Yes. Next. Okay. Okay.
Thank you very much, sir, for your wonderful presentation. So, sir, you talk about electromagnetic waves. So, and we understand that there are some rays that are harmful. So, what how safe is remote sensing on a general note? I know you are talking about the sun, that we are using the sun, but some people may come up with some ways to sense data. Because for you to sense data, you must send something that will reflect a signal back. Like in the case of radar, you send something and you receive another thing. So how safe is it? The remote sensing, the concept, does it have some future implications? I don't know if you got my question.
Okay. Electromagnetic wave is a wave occurring in nature naturally for the passive ones. We are coming to the active ones. Okay? First, the radiation. Oh, that's why you receive your phone call. Okay? It's using the radiation, the wave. That's why you listen to radio. Okay? So, nevertheless, there are harmful ones. The UV, the gamma rays, and all that stuff. Okay? If you go out in the sun, there is UV light. If you check the weather data, they will warn you when the UV light will be high, so you keep off. Stay indoor. Right? So, these are things that are already existing in nature. You have nothing to do. You cannot change it. If mankind study and understand and make use of it, okay, to solve our problem. But you cannot change it. In fact, there may be some wave that we don't even, mankind have not discovered, and it's still existing. Okay, so this is not something to be alarmed. It's just a technology, a knowledge, something that existed in nature, and mankind harness it and use it to solve some problem. Who can say phones are not good? But you are being warned that maybe phones have some radiations and all this kind of stuff. But its usefulness outweigh the disadvantages. Okay? So it's still useful. Normally, everything has advantage, disadvantage. Okay? Right. Next person.
Good afternoon, everyone. So my question is still based on the drone aspect. You made mention of that we can get the information from our house even before going to the farm. Now, with the type of drone I normally see around, or the one Nollywood normally use, I believe the person controlling it, for instance, now, I have not seen anyone staying inside something like a room like this now, controlling a drone, flying towards the gate side. You must be there either to be looking at the field to know what you are controlling. So how come now you will be in your house now and be controlling a drone maybe at the Bank of Agri side and you are not there? How possible is that? Thank you.
Okay. I mentioned that drones are of different type and different categories. You can have a small drone for just indoor, like mapping inside of continental, and you can have a drone that can go kilometers away. But why we say that you can be in your office and doing that is that you can place the drone outside. You start the drone, it will go. You can go back. While you monitor, you have a pad monitoring the drone, the location, the whatever, okay? And then when the drone finishes, normally you have to give instruction to the drone before it leaves, okay? The app you have, provide you with facilities to map out areas that you want the drone to cover, okay? And once that is done, it will come back to where it started. Do you understand? So even outside your office, you place the drone, it will go, and you can come inside. Once it's about finishing, you know that it's finished. You go out in just seconds, it will drop in front of you, and then you pick it up there. So it's about when you have a first-hand training with it, you know the usefulness and you know how to apply. All this thinking of it will, how, the only challenge that maybe some drones, even though the issue are being, gradually addressed, the issue of the battery, long state, some batteries, or even the weather can affect
because you didn't check your weather station well. You send your drone to go to Use, and before it reaches Use, there's a heavy downfall, or maybe heavy wind, you know. And the drone is struggling with the weather to the extent the battery runs down quickly. So the battery could not bring it back to your location. However, wherever the drone fall, it will be indicated on your path. So it's not difficult to locate it. Okay? But it's a challenge. But nowadays, there are very strong batteries that can last for hours, okay, in drones. So it can map a large area without the battery draining out. And even if the battery, most drones come with 2-3 batteries, okay? So when the battery is about running down, it will come back to the station for changing of battery. You can change the battery and it will go back and start where it stopped. Do you get the point? So that's fear of whether you're going to lose out or there's going to be a problem along the way. I think mostly it's being this thing addressed. Okay? And you have to be experts in flying drones, because the area you will fly, you're supposed to know the, for example, here we have high-rising building. The way you fly your drone here is different from flying the drone in your farm. Maybe in your farm, you don't have any structure more than 20, 30 meter high. Okay? While here, you have up to 50 meter high. So you make sure that the route you are setting out for your drone will not, interfere with any obstacle. So this is about experience and also training. When you are trained on how to use drone, you will be informed on all these facts, so that once you are in the business, you know what to do, and you know what to do when something happens. All right? Thank you. Any other? Yes? Oh, more questions are coming up. Yeah. Okay.
Thank you so much for your wonderful presentation.
You're welcome.
In the course of your presentation, you mentioned that we can determine the soil moisture using drone technology. But I would like to ask, how accurate is that? As in, because I'm wondering from image, interpreting the soil moisture percentage or volume from image data, how accurate is that?
Okay. Now, this question also brings us to issue of remote sensing. If you obtain an image of a wet soil, that's after rainfall, you want to obtain the moisture content of the soil, right? Now, if you obtained an image of a particular area that is maybe after irrigation, you want to know after a few days how will the moisture content of the soil be. Okay? Now, this is where we use the remote sensing techniques. You need to analyze, you need to use some algorithms that can indicate, because a soil at saturation has different spectral signature. And a soil at field capacity will have different also, because the reflectance, will be determined by the amount of moisture in the soil. So when you generate, you have that algorithm. When you get the image, you feed it in the algorithm, and it will tell you, okay, the moisture content. Because you need to build an algorithm actually that you can use the image to determine, not by just taking the image, then you can now say this is the, no. It has to pass through a series of processes. That's why you cannot separate, taking the satellite image without actually know or be professional in analyzing satellite imagery. And different methods, different techniques that are used in different software. Okay? You need to understand those algorithms and the errors, associated with it. And it needs to take a series of training, over training, then you master it to the extent that wherever an image is sent to you, you should be able to tell this is the moisture content of that soil. Is it clear?
All right, thank you. Next person. Please take the mic. It's like almost everybody has a question.
Thank you very much, sir, for this wonderful presentation. Sir, you have mentioned detecting crop health. So what does that actually mean? Does it mean only under or over irrigation, or there's more details to that crop health?
Okay, yeah. This is where he's talking about application of NDVI, Normalized Different Vegetative Index. Actually, this is to the image after process under NDVI. The image will indicate whether the plant is healthy or there's a problem based on the NDVI value, isn't it? Now, water stress affects the leaves of a crop, right? When there's water deficiency, the plant loses its vigor. The plant's leaves become, okay, stressed. Stomata tends to close. The plant become weaker. These are all signs that the plant is under stress. At that point, if you conduct the NDVI, you will see it will give you low NDVI, because the chlorophyll level also declines. Because when plant is showing stress of water and even approaching to shelf these leaves, the leaves turns yellowish and even, you know. So this method is used to determine whether the plant is healthy or not. That is on the side of water. There is also an issue when there's a disease infection. When there's a virus attack, okay, like the blights, you know, the leaves become yellowish or brownish in color with a spots, okay, brownish spots on the leaves. That's a sign of disease, right? Or deficiency of some micronutrients. So if you have those image, you can correct the problem immediately. We are not talking about an acre of land, or maybe 1 hectare of land. We are talking about hundreds of hectares of field. Okay? Please bear this in your mind. When we are talking about application of all these technologies, the satellite, we're not saying you cannot use it on 1 acre. But what we are saying is that mostly you apply this for a large scale farming. Okay? Because that is when it will save a cost. But for a small scale, it may not, because those technologies are very expensive. The processing of data are also expensive, you know. So you need a very big investment so that you can deploy this technology. Is it clear, sir? Are you okay? Yes. All right. Any other question?
Sir, I have a comment. Sorry, sir.
Okay, comments. You're welcome.
Sir, looking at the importance of this hands-on training, sir. We used to have annual workshops, the NINSEED annual workshops, which papers, we have technical sessions that papers have been presented and so on. So I want to make a suggestion. Maybe we can have a parallel session for the young professionals during such workshops for us to have this hands-on training. While the workshop is going on, maybe you can have a side function for this hands-on. It's just a suggestion, if it's possible.
Okay, thank you. I think the representative of young professional is listening. Yeah, so what he is saying, I don't know, you have something to say? To cool his mind down, please, because I can understand he just want to get that hands-on quickly.
Is noted, sir.
All right. So I think we have exhausted all questions. So, let me also thank you so much for listening to me. I hope this type of talk will continue, but time is always, the ant. So I thank you very much for listening, and we hope that we meet sometime to discuss and learn a lot on these technologies. I thank you very much, you guys. I thank you for giving me the opportunity to talk to you.
For him, please.
And
thank you very much.
You're welcome.
While we wait for the next class, okay, he's still busy. Please bear with us while the lecturer is getting ready for the next class. Thank you. Okay. Okay, for those of our Muslim family that wants to go and pray, you can use this opportunity while the lecturer is on it. That's why I don't want to rush you. Just take your time. Yeah. Yes, please. Just take your time. Thank you very much. Yeah, go ahead, please. to walk around while we wait for the others to come in. Just stretch your legs. Just do what you think will be fun to you. Have fun while we wait for the lecturer to come. Having fun doesn't mean taking pictures. Anthony? Anthony. Let's go. If you're okay, no problem. Yes, that's the interaction. But so that's it. There's no creativity. Okay. All right. Thank you. Please, let's all get seated. Okay. Okay, please, we're about to start. Coming. Okay, the next lecture will be on climate resilient irrigation practices, strategies for adapting irrigation practices to cope with climate change impacts, including the drought-resistant crop and efficiency water use. The presenter is Prof. S.M. Musa, ATBU Bauchi, Nigeria. Please, let's welcome him as he makes his way. Round of applause for him, please. Please, let's encourage him. Thank you.
Okay, are we ready? I can see more people coming in, so let's try to settle down a little. I think we can have the slides up. Let me start by welcoming everybody to this session. From the program, this is going to be the last lecture for this workshop. And I understand that what's happening on the slide, please? Very good. We are back and on course. Like I was saying, this is going to be the last lecture for this workshop, I understand. Initially, we were allotted only 1 hour for the presentation, but I understand that we have a lot more time to discuss after the presentation. So whatever it takes, we will make the presentation and we may have some time to discuss some of the issues. To start with, I'm Engineer Professor S.M. Musa from the Abubakar Tafawa Balewa University in Bauchi, Bauchi State, Northeast Nigeria. We are going to discuss issues related to climate resilient irrigation practices, meaning that we are aware that there is climate change and that we are aware there are irrigation practices and that not all irrigation practices are climate resilient. So we shall concentrate our efforts on identifying some strategies that we can adopt to mitigate or create resilience for the all-important climate change impacts that everybody is experiencing. During the discussions, we are going to look at issues related to climate change, irrigation, and food production nexus. Because the whole idea is we want to manipulate the relationship between climate change, irrigation, in order to produce more food for the population. And in Nigeria, we know that the Nigeria's population is fast increasing. We're going to show some statistics later on. Then we'll look at the impacts of climate change on irrigation specifically, because climate change is a global issue, it's also a regional issue, it's also a local issue. And it can affect different sectors of the society. But in this case, we are specifically concentrating our efforts on irrigation itself. And then we look at a few things about innovative irrigation technologies. The lectures from yesterday to this morning have dealt with quite a lot of these innovation technologies in irrigation. So when we reach there, we're not going to waste too much of our time on that. Then where we are going to concentrate is what are the key climate resilient irrigation practices. We shall identify a few here, discuss them globally, and try to put them in perspective. We have identified about 4 key ones that we are going to discuss. We are not claiming that these 4 are exhaustive, purposes for which it was intended. Apart from water resource management, there are quite a number of agronomic practices that are required to ensure that you adapt and mitigate climate change in the practice of irrigation. And then, of course, the concept of adaptive research, which is a concept that tells us or gives us an opportunity to look at available technologies and see how to adopt them in our local environments for our local use. Then, of course, we know that whatever we are doing, they are being regulated. That whatever we are doing, they are being regulated by policies of government and institutions that have been set in place to implement certain objectives. And then we conclude from all the discussions that we have. So now, to start with, Nigeria's population is estimated to reach about 400 or 450 million by the year 2050. Meaning that now we are talking of 200 plus. Meaning that in the next 25 years, the population is likely to double. And when the population doubles, it means that our food production at least must double. Even if it is assumed that at this time, we have adequate food. But even at this time, we are not food secure, because food security has not been achieved. Food security, you remember, is the availability of high quality food that is available to everybody, to your preferences, and many, many other parameters there. So we are not yet food secure. And when the population is increasing, it means that we need to really step up our production techniques and increase the level of production of food in Nigeria. We are also aware that about 70% or more of Nigerians are engaged in agriculture, mainly at subsistence levels. So we have to move from subsistence level to really large-scale commercial production. And this is a major challenge for everybody in the country. Again, even though agriculture is at subsistence level, it is one of the significant contributors to the national economy. In the recent years, agriculture has been contributing in the range of 20 to greater than 20% of the national GDP. The exact figures keep on changing, of course, on a quarterly basis and on an annual basis. But we know that nothing less than 20% of the GDP is being contributed by agriculture and agricultural practices. And we also believe that irrigation has the potential to improve and increase food production. In Nigeria, we have the potential for irrigation. Well over 3 million hectares are available, are irrigable. But at the moment, we have, I think, less than 1 million hectares that is being actually irrigated. About 1 million hectares is under public irrigation, and another 2 million under states and ADPs. And of course, there are other private sector ownership, small scale levels ownership of irrigation systems. But the important thing here to mention is that we have a great potential for irrigation development in Nigeria. So, when we want to try to understand climate change and its effect on irrigation and food production, first we need to understand what is climate change in the first place. The global definition, there are many definitions, but one of them that we can take is that climate change is a long-term change in the average weather patterns that have come to define the Earth's local, regional, and global climates. This is one of the simplest definitions of climate change. But that there are several other definitions by several organizations that are operating across the globe. The major causes are the greenhouse effect, which is the warming of the global system that results when the atmosphere tries to trap the heat that is radiating from the Earth towards the space. And that is why carbon dioxide and methane gases that are being generated have been the major culprits that contribute to global warming. And that is why in every practice you will hear people talking about reduction of greenhouse gases. These greenhouse gases are the ones that are responsible for trapping the heat and encouraging temperature rise across the globe. You may not experience it immediately. It's a long-term process, but it is happening. So the effect is that the rise in average temperatures across the globe, there are changing precipitation patterns, and there are increased flooding and in some cases even drought. So the effects are wide and interrelated. So if we understand climate change in this perspective, how does it really affect our food production strategies or production systems? Agriculture and food production system is unable to keep pace with rapid population growth. Like I told you earlier, Nigeria is classified as food insecure, meaning that we don't have adequate food for everybody. Food is not easily accessible to some, and even the quality may not be very high. You may not eat what you want at the time you want. So all those are components that constitute food security, and the population is increasing. So actually the situation is exacerbating, and if we don't do anything, then the situation is going to get worse. We are aware that irrigation is one of the key sectors that would ensure food security in Nigeria. And climate change has a major impact on the ability for farmers to produce more. We shall see the reasons why when we look at the impacts of climate change on irrigation. And therefore, we must develop climate-resilient irrigation practices to sustain production. In fact, not only sustain, but increase and sustain production of food. Okay? I have made a small slide here of some of the impacts. We're not likely to discuss discuss them in detail. But what we know is that as a result of climate change, we have reduced water availability. Where you are experiencing erratic rainfall, okay, unpredictable rainfall, you may be having, even if you are rain-fed, in some areas you may be experiencing rainfall for 3 months, 4 months, 6 months, and you discover that over the years, the growing period is decreasing. This, the beginning and the cessation of rainfall keeps decreasing. In this country, we are lucky. We have a variety of vegetation and agrogeological areas from the south with rainfall between 2,000, 3,000 millimeters up to the north where you have less than 500 millimeters of water per year. And so, and when coupled with this variability, if there is unpredictability, then the problems become more. So there is a need, therefore, to improve on how to make use of the available water resources that we have. Climate change also results in moisture depletion. If the temperature has increased, it means that the rate of evaporation from the soil surface will increase, and the available moisture to soils will therefore, to crops in the soils will further decrease. And that means you need to do more irrigation in order to sustain the crop for the same period of time we are irrigating. And that has serious implications on so many things. The availability of water resources, the cost of operation, your production, and so on and so forth. So these are serious factors that affect irrigation as a result of climate change. And of course, the hotter the weather, the more the crop requires water, and the more investments you have to make for equipment and also for personnel, for operations, and so on and so forth. Innovative irrigation technologies. Like I said, from yesterday to this morning, we have been discussing on several innovative irrigation technologies. We can categorize them into different classes: drip irrigation, smart sprinklers, control environment irrigation that involves greenhouse practices, hydroponics, and the rest of them, and drought-resistant crops. This is an agronomic approach where you adopt or you breed crops that will require less water. Maybe you will shorten the growing season. Maybe you will give them genes or characters that will make them have deeper roots, or some of them that may be more resistant to water stress, and they should be fast growing in order to be able to produce within the shortest period of time. Details of this have already been discussed yesterday and this morning. So we come to the main part of the discussion this afternoon, which is the key climate resilient irrigation practices. I mentioned that we have identified these 4 key practices to look at in some greater detail, but nobody is claiming that this is an exhaustive list. We are not claiming that this is an exhaustive list. It's a list that will help us to identify and understand some of the major practices that we need to understand and adopt in order to mitigate the effects of climate change on the irrigation practices. First is we adopt smart irrigation technologies. If you recall, in the previous lectures, we were given so many different techniques: drip irrigation techniques, solar-powered pumps, AI-generated data, and many other things to help you in crop scheduling, knowing when to apply water, how much water to apply, and so on and so forth. Now, those are the practices. But those are physical practices. We need to do certain practices too in order to make use of those technologies. One of them is the fact that we must monitor the weather situation. weather monitoring gives us the required data to make these technologies function. Without the weather data, you may not be able to make use of any irrigation scheduling software. So making data available is very important, and generating it, storing it, and retrieving it as much as possible. If you look at some of the sections in the National Irrigation and Drainage Strategy Plan, you see that there is a section there where government is emphasizing the need for the generation of data. And this is also a very important key for us to be able to achieve resilience in irrigation under the climate change situations. We need to also massively invest and promote private-public partnership. What we are talking is that yesterday somebody was talking about the costs of this smart irrigation equipment. It's so costly that ordinary farmers may not be able to make use of them. So if there is a deliberate effort to subsidize these costs, more and more farmers will be able to have access to some of these technologies and make use of them. And in fact, one of the best ways is for government to adopt this PPP practice where large-scale investments can be done by private sector in order to ensure that we have appropriate irrigation practices in place. During the conference, this is one of the sub-themes for our discussions, and we believe that so many papers will be presented to elucidate more on some of the areas where we are going to benefit more by adopting the public-private partnerships. Participatory cadastral mapping of plots for better land tenure. If you go to certain irrigation schemes, large irrigation schemes, this is one of the key problems that we have. Managing the land, allocation land for farmers to practice their irrigation. And if you computerize your mapping of plots and so on, that will make life much easier and make land tenure systems and, of course, mechanization also a little bit much easier. The next approach that we need to adopt in order to be resilient to climate change in irrigation practice, I've also given a few of the areas where we can make efforts. Watershed management. This is not water resource management at the field level. We're talking of watershed management in terms of the complete catchment that consists of both the schemes and many others in the area, including domestic water supply and industrial water supply. So there must be some coordinated effort between the irrigation sector and the other sectors that require water in their operations. And we know that the agricultural sector is the one that uses water most, and in many situations, most inefficiently. So there is the need for an integrated and strategic watershed management between all the subsectors that are using water within the catchment. Okay? Groundwater recharge is another. Here, there are situations where there are no subsurface, there are no surface water resources available for irrigation. But you can drill boreholes, you can drill tube wells, and do your irrigations. I happen to come from a rural area. About 20 years ago, we only practiced irrigation just on the floodplains of the local river that passes through the village. But nowadays, even on the upper plains, people drill these boreholes and extract water and irrigate. And if you go to the rural areas now, you will see spots of greenery across, unlike before, that once it is dry season, you only see the brown grasses and the red soil all over the place. So people are exploiting the available groundwater there to irrigate during the dry season. And if an integrated way of managing this groundwater is not developed and adopted, then there could be problems in terms of aquifer depletion or water level decrease. Rainwater harvesting is another technique. It's an alternative source of water. People in areas where rainfall is not very much, you can practice rainwater harvesting to improve on your water supply status. And of course, there are many other alternative ways of making water available. For example, wastewater reuse. Okay? These are all ways and means by which we can improve on the total water supply or water availability to farmers at any given time. At the extreme level, we even have saline water desalination, where the seawater is being desalinized and being used not only for irrigation, but also for water supply. So these are many, many techniques that can be adopted depending on your situation and your location and the availability of investments to make some of these things happen. Now, when I'm talking of watershed management, I'm talking of water resource management at the watershed level, not at the irrigation field, not only at the scheme level, but also at the catchment level, okay? Like for example, you can look at how does a state manage its own water resources, okay? In relation to other water uses, industrial and domestic uses, okay? So that you balance the uses and have an equitable distribution within the available resources you have. Now, apart from smart technologies, apart from water resources management, you also need some smart agronomic practices on the field. I don't think anybody or nobody is aware of what we mean by mulching. It's a very simple technique of retaining moisture by reducing surface evaporation, by covering the soil surface with any available material that will reduce the impact of the solar radiation on the soil surface. It is a technique that is very potent, and it can reduce your water requirements. Cover cropping is one of them, which enhances the health of the soil and the water retention in situations where you grow different crops that will give cover to the soil and increase maybe organic matter content and other nutrient content making devices that you'll be able to improve the fertility of the soil by growing some of those crops. We have talked of the selection of drought-resistant crops earlier. When you select a crop that you know can grow under stressed conditions, and that way you'll be able to succeed. Otherwise, for example, you can't go to an area where the total rainfall is about 600 millimeters per annum and try to grow crops that require 1,000 millimeters of water. Yesterday, we defined the concepts of the water requirement of crops, and we did the computation to imagine the quantity of water that you need to produce a certain amount of crop here. Okay, so drought-resistant crops will help us to cultivate several varieties of crops that require less water, or crops that will grow at a shorter period so that our water requirement will be smaller and smaller as the case may be. Also, I think yesterday we discussed the concept of deficit irrigation. Deficit irrigation is a practice whereby once you identify the crop growth stages that are less sensitive to water stress, then you withhold the supply of water. Okay? and ensure that the crop is supplied with the adequate amount it requires at its most sensitive stage of growth. If you make the mistake of allowing the crop to be stressed during its most sensitive stage of growth, you would have lost a great percentage of your production, even if you are able to bring back the water supply to the required level later. Now, there is a concept we call adaptive research. When we are talking of all the equipment, all the practices, the agronomic practices, water resource practices and everything, somebody has to put it into effect. Somebody has to practice those things in the field. And the only way, or one of the best ways to do it, is to adopt this concept of adaptive research. And by definition, an adaptive research is any research that is designed to solve a specific problem or for a specific stakeholder. Now, you can be a consultant and somebody will tell you that on my farm I have problems of how to grow tomatoes. You go to the farm, you look at the type of soil that he has, you look at the available water that is around, and so on and so forth. Then you have to recommend to him the best irrigation practice to adopt. And in doing that, you may have to do some on-farm experiments to determine which is the best approach. Also, it is defined as a process of domesticating a technology to a specific agro-environmental conditions. We may also look at adaptive research as an on-farm adaptive research. This, I'm sure you must have come across this, where yesterday when we were talking of, when Professor Igbadun was talking about demonstrating the use of certain techniques. You allow the farmer to do his own, you go and do your own by his side. And each one of you will be practicing your own according to this. And at the end of the day, you may be lucky to succeed that your method produces more, and then he will be interested in adopting your method. That's one best way to ensure that some of these new techniques that we have been talking about are adopted by the farmers. Okay? Of course, it is also an avenue for us to disseminate our technical research results. We do research in the universities and the research institutions, and we have to use adaptive research to popularize it and make it available to the farmers for adoption. We have two different ways of doing adaptive research. One is what we call the participatory adaptive research, where the farmers are involved or stakeholders are involved. The other one is the intellectual adaptive research. You as the professor or the research fellow will be engaged in your own laboratory or in your own workshop in order to develop a certain process or a method of doing certain things. And then when you do that, then you have to take it back to the field to try it. So we have two methods of doing that. In the intellectual adaptive research, you may be interested in modifying a certain machine to adapt to your local environment. Or you may be interested in reconstructing something that is already existing, but you want to adopt it to your own local environment. What do we benefit from adaptive research? We promote the uptake of new technologies, we increase level of mechanization of agricultural activities, and also we support standardization of agricultural equipment, because unfortunately in this country we have so many universities and many research institutions doing research on so many things. Everybody is doing his own thing in his own silo. And at the end of the day, all of these things are not taken up or are not fully commercialized. So there is the need for us to be able to have strategic research and standardization of all of these machineries and equipment that are being developed in various research institutions and universities. We can also use adaptive research to collect, package, and disseminate research results for adoption by diverse users, validate appropriate technologies and innovations that support dynamics of irrigation value chain. When we talk of irrigation value chain, it is not only the application of water to the soil for the crop use that is irrigation related. You may be talking of the harvesting equipment. You may be talking of processing equipment. All of these constitute the value chain. And researches in those value chain sectors will help us, adaptive research will help us to come up with innovations that will intervene in the various value chain subsectors. We also use adaptive research to optimize water use. Also, it's imperative for the physical and socio-economic conditions under each irrigation system. It promotes sustainable land and water management as well as biodiversity conservation and so on. All these are concepts that relate to adaptive research. We do adaptive research in so many areas. Let's say we have identified some of these: adaptive agricultural mechanization, irrigation infrastructure, adaptive agronomic researches. You recall we identified many agronomic practices by which you have to go to the field, try them, and ensure that you determine their efficacy and applicability to particular regions. Because there are certain practices that are not suitable for all environments. Irrigation, water management research, and artificial intelligence in agriculture. These are some of the major areas through which we do adaptive research. Mechanization, the objective is to reduce drudgery. This is one of the things that is pushing away the youth from agriculture. The usual traditional method where you have to bend down with the hoe and do things, people are not interested. But if you have machines that can operate and do these operations easily, I'm sure many of you must have on YouTube or on Facebook, you must have seen some of these little machines that the Chinese are developing for weeding, that you just push a machine like that and then you weed the farm. So these are some of the areas that we could also put our efforts into to produce some of this equipment that will help us to mechanize processes like planting, weed control, harvesting, and even transportation from the farm to wherever you want to take it to. Okay, develop indigenous machines for farming and processing techniques, standardized agricultural machines. There are many universities and polytechnics, like we mentioned. In Nigeria, the National Center for Agricultural Mechanization, situated in Ilorin, is the body that has the mandate to conduct some of these standardizations of agricultural mechanization in relation with the Nigerian Standards Organization. Okay? And they have been so busy over the last 20, 30 years, they have produced quite a lot of some of these machinery, mechanization equipment, both small and large scale levels. And every year they do an exposition. And I will encourage you to monitor and be able to participate in some of these agricultural machinery expositions that are taking place, so that you can see the variety of equipment, implements that they have developed for not only irrigation, but also some other agricultural practices. I have a few examples of some of these machines. This machine was produced, I believe, in ABU's. This is a multi-crop thresher that can thresh beans, cowpea, groundnut, maize, millet, and the rest of them. Those ones, I think this is a maize planter from Trimin project. And that one is also another planter from Nka. Infrastructure development. Adaptive research and irrigation infrastructure development. We need to develop the hardware. Water lifting, for example. I don't know, from yesterday to today, we have not talked of water lifting devices. But we need water lifting devices to irrigate. So somebody has to do a lot of work to produce different kind of pumps. We have talked of solar pumps, but who produces these solar pumps? We have to produce these pumps that will help us lift water from the ground or even from the surface reservoirs and distribute them to the various parts of the irrigation scheme. Okay? Some of the other innovations in irrigation infrastructure would help us to optimize the distribution of water to guarantee optimum growth, whereby we make use of all those other equipments that we are talking about. Irrigation water management will involve the adaptive research on the use of soil moisture measurement sensors. We have talked about them, but we need to able to teach the farmers to be able to use some of these things and apply them on their fields, where you are also using some of the programs that are developed for irrigation scheduling. At least the farmer needs to have the basic information or the basic background on some of the programs that he is using to determine crop water requirements and to develop irrigation scheduling technologies and so on and so forth. I think we have covered agronomic research. We have covered this, sorry, it's a repetition. Artificial intelligence, we have also talked about this in much detail. The previous lecturer this morning, he has spoken on this today and yesterday. We deploy the use of Internet of Things to employ and to control multiple of digital farm equipment, machines, and robots to perform tasks related to planting, weeding, spraying, selective harvesting of fruits, sorting, and damage detection. These are all value chain processes and practices that are required to be able to achieve all of that. Now, all these things we are talking are technological, and they will require some policy and capacity building for them to succeed, because each one of them is not likely to succeed just on its own. So, and government and the general public need to be carried along in ensuring that some of these issues are implemented according to the strategic requirements for their function. Strategic water governance policies are there. I think we have the Water Resources Bill, which has not yet been passed by the National Assembly. Is anyone aware of the National Water Resources Bill? You are not aware? It has not yet been passed. It's a very good bill. It is only being encumbered by politics and issues like that. But I think by the time we're able to do adequate advocacy with the members of the National Assembly, we should be able to make them realize that there is a need for us to have that national water resources policy that would help us to make use of the available water resources in the country most judiciously and efficiently. The issue for us to do in terms of ensuring water, efficient water governance is we need to generate data. We have mentioned that earlier. In order to help us regulate and monitor the use of water from time to time and ensure equitable distribution of water resources within the catchment area, and that's what we call the watershed management. And of course, strategic water governance will ensure participatory irrigation management to give us the best results from the available water we have. Incentives for sustainable practices. Like I mentioned earlier, these practices are costly, and therefore, for people to be able to acquire these new technologies very costly, we need some subsidy and ways of making it available to farmers in whichever way you can do that. PPP arrangements that will also help in funding and managing large-scale irrigation schemes and infrastructure will be very important for us in this regard. Okay? There was an advocacy for establishing what we call irrigation maintenance service provider, and irrigation maintenance fund. We need to support the river basins to be able to deliver their mandates of not only developing the available water resources, but also managing the irrigation schemes within their jurisdiction. Farmer capacity building. The farmers need to be aware of some of the global impacts of climate change and environmental sustainability. They must appreciate this in order to be able to adopt some of the techniques we are advocating. Yesterday we have heard of homestead micro irrigation practices. This is one very key area where food production can be improved, because you can practice some of these homestead micro irrigation practices even at your own backyard. Even if your house is fully concreted, you can grow tomatoes, you can grow spinach, you can grow so many things in bags or in the hydroponic systems that we have been mentioning. So there is the need for advocacy and building the capacity of the farmers and the general population on some of the areas whereby they can practice irrigation in order to fight climate change. Investment in rehabilitation of public funds. I believe each and every one of you here is aware of TRIMIN. TRIMIN, that is Transforming Irrigation in Nigeria. It's a World Bank sponsored project that has worked in 3 or 4 major river basin development authorities up in Sokoto Rimako, the Transforming Irrigation Nigeria, 3 RBDS, the Sokoto Rima, Hajes Jamare, and Upper Benue. Okay? They have worked over the years, and they have invested a lot of money and time in rehabilitating infrastructure for 10 years. Hectares have been improved over these 10 years. So, and this is a big recipe for success or improving the irrigation practice in those particular areas. So, investing in the rehabilitation of other infrastructures across the country would definitely have a positive effect on this. They have also worked very hard on establishing and strengthening what we call the Water Users Association. These water users associations are the people that are on the ground making use of the water to irrigate, and they are very, very useful in ensuring that water resources are efficiently used for the services they are intended for. And then they help in the operation and maintenance of all the infrastructures on their fields. Investment in youth, women, and land tenure. This is where we are advocating that women and youth should be specially targeted. There should be special programs that will target youth and women. Yesterday, somebody was advocating that federal government should give 50% subsidy on some of this equipment. I can see her on the other end there. So I think we are with you, and we hope that even if it is not 50%, at least there is some targeted program that aims at improving the participation of women in irrigation, or women and youth, in fact, in irrigation, so that we'll be able to fight climate change and improve on our food security in Nigeria. I have mentioned the issue of land tenure. I think this is one of the issues that TRIMIN had worked on in the, which one of that? The Upper Benue scheme, Dadinkowa scheme. They have tried that, and a lot of challenges are there in the land tenure systems under large-scale irrigation systems. And there is the need for us to streamline those and formalize it through mapping of high potential localities and so on and so forth to ensure that some of the advocacies or some of the processes we are advocating can efficiently be implemented. By way of conclusion, what we are trying to say is that adopting irrigation can help us to achieve resilience against climate change, because it helps us to make use of the available water resources we have as efficiently as possible, and it helps us in improving crop or food production. We need to combine technology, crop choices, and policies in order to achieve the mandates or the expected results of climate change resilience. And of course, we need to collaborate for any particular impact that can be scaled up from lower levels to higher levels. And I think with this, we can open the floor for any questions and comments as the case may be. Thank you very much for listening.
Thank you very much, sir. Please, questions? Any questions? Ask your questions. All right.
Thank you so much, Professor. Yeah. As regards the integrated water resources management, that you mentioned the use of boreholes, I mean, taking a groundwater source as an example, okay? So let's say in an area where I want to grow a crop that has high water demand, like more than 1,500 mm. So like how many numbers of boreholes can I dig in this area that will not lead to the aquifer totally depleted or causing subsidence?
Yeah, thank you very much. This is a very technical issue because there are many issues or many factors. There are many issues that you have to look at. You know, aquifers have different characteristics. And if you are drawing water from a particular borehole, aquifers where you draw water from underground have different characteristics. Depending on the characteristics, when you draw water from a particular aquifer, the radius of influence we talk of will be related to the characteristic of the soil material underneath. So it will require a lot of field studies to be able to know the water yield from a particular borehole and the rate at which you have what we call the drawdown as a result of pumping, so that you don't have a one-fit-all approach to determining how many boreholes you need, because it also depends on the yield of the boreholes. Some boreholes can give you very high yield of maybe 50 liters per second, 100 liters or more. Some will only give you a few liters per second. So there are a lot of technicalities and feasibility studies that need to be carried out in order to determine how best to, first of all, space your boreholes in order to ensure that you are not mining the groundwater underneath and therefore lowering the water level excessively. That would have negative effect at the end of the day. Thank you. Any more questions? The moderator is out, so let me take the role of
Thank you very much, sir.
Yes.
We really appreciate your presentation.
Thank you.
So my question is on the watershed management. You say on the integrated level, we should be able to moderate, manage the catchment area. So is it the state that is supposed to look into this? Because, you know, states have power over some certain activities, or the river basin within that catchment area. Who is to take responsibility of managing the watershed? Thank you.
Yeah, thank you very much. This is where that concept of water resource bill comes in. Because the water resource bill has all the details about how to manage the water resources in each particular. I hope you know in this country, we have about 8 hydrological zones that have different catchments and water systems. And the water resource bill has set up a procedure and methods by which you can manage available water in each of those particular hydrogeological zones in the country, taking into account the rainfall patterns, the agricultural practices, and the water requirements, and all of those factors that are required to ensure that the water resources available are judiciously used and equitably used by different users. The watershed management issue, like I mentioned, is not something related with only irrigation. You have to take into account the water supply to the towns and villages. You have to also take into account water supply to various industries that are in the area, and so on and so forth. And then you work out an equitable way of sharing the available water in the zone for efficient and sustainable usage, okay? And making sure that the environment is not negatively impacted upon. Yeah, thank you. Any more? Yes, is it the 50% discount? Okay. Yeah, no, it's okay, you get that. In fact, you may even get more than 50% discount. Or subsidy, sorry, not discount.
Good afternoon, everybody. Thank you, Professor S.M. Musa, for a beautiful presentation. I just need clarity on what you mentioned, and I've been hearing, water is scarce. We need to maximize water. And to the best of my knowledge, I know some areas are flooded, and we have enough rainfall. And definitely there is water in our soil. So I need clarification on how water is being scarce and how we need to maximize it.
Very good. You are not a farmer. You are not a field farmer. That's why you are saying it's scarce and it's available everywhere. If you happen to be on a large-scale project and something happens, by chance, you are at the downstream end of the system, you will always be struggling to ensure that water is supplied to your own end. Even though in the whole scheme, water may be there, but issues related to, for example, conveyance losses and even illegal withdrawal of water along the water courses and so on would make water scarce for you at the extreme end. But anyway, when we are talking of water is scarce, we are talking of, first of all, depending on the type of use, okay? Are you talking of domestic use? Are you talking of irrigation? Or are you talking of industrial? And also, we are talking in terms of the supply at a particular time, depending on the seasonal variations. And across the country, you can say that, yes, we have abundant water supply. But if you look at the standard per capita water requirements for each individual, we don't have enough actually. Only trouble is that the available water is not equitably distributed. Some people will have excess, while others have scarcity. But on a general note, if you look at the availability of water and the theoretical per capita requirements, we don't have adequate fresh water for everybody. Okay? But it may be an illusion. Somewhere you have flood. But even in the flooded areas, like now, if you go to Maiduguri, where we had the flood in September, when the whole town was flooded,
Now, when you go there, you won't see any water there. All the water has gone. And in fact, people are now looking for water to drink in so many places. So it all depends on the space and time at which you are talking and operating. Okay? Somebody somewhere here? Yes.
Well done, Prof, for a very good presentation. My question is about this deficit irrigation. Can it be practiced on a local scale? Since deficit irrigation is a system whereby you intentionally withdraw the supply. So without those sophisticated sensors to tell you when you need to irrigate on a local scale, how can you practice deficit irrigation?
Yeah, thank you very much for that one. There was a time we went for a field trip, and we went to a farmer's plot, and we saw his plot is dry. We said, why didn't you irrigate these plots? He said that no, at this particular time, he doesn't irrigate them. I think he was growing pepper or something like that. I don't know. He says that he is training the crops. He is training the crops. But the issue is, he is using his indigenous knowledge of irrigation practice to make sure that he gets the most out of his crop. Those crops, he says, once you train them and you give them water later, they grow faster. So anyway, what you are asking is how and when do you practice deficit irrigation? We have defined deficit irrigation as maybe the supply of minimum amount of water to the crop at certain stages of growth that is not sensitive. And every crop has a sensitive stage during which when you stress it, you will lose a great percentage of your yield, even if you irrigate it later. So to be able to identify that, you need to do certain adaptive research to ensure that you determine the number of days after transplanting that the crop is more sensitive and is not more sensitive, and so on and so on. And then you can also use some other techniques, local techniques of irrigation scheduling, by looking at the crop characteristics that shows some elements of stress from the leaves, either leaf curling or change in color and so on and so forth. Or even some of the rudimentary soil moisture measuring techniques by the field and many other methods by measuring moisture content. But this is just at a local plot level that you are thinking of. And we have always been emphasizing that please, when we are talking of some of these techniques, we are talking of large-scale systems where people are producing hundreds and hundreds of hectares. But of course, we don't want to leave the local peasant irrigator. We can, I think yesterday Professor Igbadun was talking about irrigation manual for such farmers. So if we're able to get hold of that, we should be able to go and train those farmers at that level. But some of these concepts we're talking about are mainly for large-scale systems whereby we are producing hundreds, if not thousands of hectares at a time. Okay? Are we clear? Somebody is...
Good afternoon, sir.
Good afternoon.
And thank
How are
you
you?
for wonder. Okay. So now. So
Is there?
It's okay. Thank you, Prof. Mine is not really a question, but I just want to contribute to that aspect of climate smart practices. In doing climate smart practices, with irrigation smart practices as well, a farmer can get it right with the scanty rains in some parts of the country we have as now. If we experienced like last season, we had a delay in at the vegetative state of our crop last year. We had some like 3 weeks drought period. Research has shown, and we have access to it, to some smart seed also that is adaptable to each region of this country. So while we want to irrigate, you can take advantage of making use of those hybrid seeds that are climate smart as well. There are some for 60 days, there are some for 90 days, and we have some of 120 days, depending on the region you come from in this country. So I just want to chip in that those facilities are readily available, and if you wish to have it even in tons, we can make supply of that. Thank you.
To help you, are you advertising? Which one? Where are you from? Are you from a private sector or from government? River Basin? Okay, which river basin? Upper Niger is around Mina area. Yeah, I think this is why we're talking about the agronomic researches that we need to conduct. Genetic engineering of crops to adapt to certain situations or conditions, isn't it? And then by reducing the length of growing season, you will be able to produce even in areas where the rainfall is scarce or the growing period is short. So I think, like he's saying, he's adding to our knowledge that some of these things are available in the country, and that is why you have to also be conscious. The National Meteorological Agency always gives us these predictions at the beginning of the year to tell us when the rain is going to start in which area. In fact, all the local government areas, they give you an estimate on when the rain is going to start and when it is going to cease. And you can take advantage of that to ensure that you select the right crop and you plant at the right date. Because planting date is very, very important in the agronomic management practices that you have to adopt. Even irrigation, there are specific times that you need to really irrigate, plant. For example, if you are growing wheat, wheat requires, I think we said about less than 10 degrees centigrade in the night to germinate and continue to grow, and maximum temperature of 28 degrees during the daytime and things like that. So in the north, we have that situation only between October, November, December. So if you don't plant your wheat as late as mid-November, you are not likely to get any yield from your wheat, because the temperature would have risen to a higher level that it does not require, and you are not likely to succeed in that case. So you must plan to produce or plant at the right times, and some of these predictions are very useful for us to be monitoring and enforcing if we are really practicing farmers on the fields. Any more?
Yes, sir. Thank you, sir.
I like some of these questions because it helps us to understand more of the concepts we are talking about since.
Yes, sir. Thank you very much, sir. Yes, during your presentation, sir, I didn't hear any mention of manure or fertilization or fertilizer. Does that have any consequence on this smart irrigation? Thank you.
Thank you very much. Remember, I said our discussion is not exhaustive. And, well, of course, if you talk more to a soil scientist, he will be talking more of fertilizer use, manure, and the rest of them. Yes, it is very, very important too. There are different kinds of fertilizers that are available that can be applied to different soils. And he will also tell you that before you apply any fertilizer, you must carry out a test to determine what type of fertilizer you need to add. But you know the challenge we have now is we have few varieties of fertilizers, and farmers apply any one at any time. So that too is an area that requires a lot of attention in the area of agronomic practices for irrigation, not only for irrigation, even for the rain-fed farming.
so that you can carry out a field study. If you recall about the aerial drones, which you can use even to detect areas that are affected by some nutrient deficiency. Okay? But you need the data to be able to interpret what the drone will collect for you from the field. So all of these things are really required in the country. And that is why multidisciplinary approach to the whole issue is very, very important. It's not only for irrigation engineers, it's not for agriculturalists, it's not even for sociologists. Even those people studying political science are important in one way or the other in the policy drafting and implementation and so on and so forth. So it's very important. Well, it is important that we consider the issue of soil fertilization and the rest of the, and yes, please. We carry on until it is time for lunch.
Thank you, sir.
Yes.
My question goes on like this. Thank you for a very sound technical presentation of the paper. But before you go ahead with your lecture, you were mentioning about the food security challenging that we are having, so huge in the country. Now, my question is this: why are we having that gap, that heavy gap for that food security challenging? Is the country lacking vision, or is the country don't have the capacity to pursue agriculture, or the country don't have the capital intensive to embark so that the country can have a very good, maybe have a food security available to the doorstep? Thank you, sir. Maybe you can address that.
Thank you very much. You remember the initial statistics I showed, the very first slide, that I mentioned that about 60 to 70% of the farmers are subsistent farmers. Abi? Well, the 60 to 70% of the farmers are subsistent farmers. Now, there are some people that have farms that are less than 1 hectare. All that he produces is not even enough for him, for his family for the year. And they are all over the place. And you have heard of the fact that one person who has maybe 3,000 hectares of land can produce food for how many people? So the issue is we are dependent on, first, rain-fed agriculture, which has very high unpredictability. You can't be sure of what you are going to get at the end of the season. You have no control of when the rain takes place or not. 2, we have subsistence farming only. People that have very small pieces of land to cultivate, and they are the majority. They are not even feeding themselves, not to talk of others that are not practicing the farming practice. 3, we don't even have enough inputs for those farmers themselves. If you go to any particular rural area during the growing season, you will always, you only ask them, what is your most important problem? They will say lack of fertilizer. Even though they don't even know the rate and the quantities to apply, but they still need that fertilizer to apply. So the issues that bring about lack of food security in the country are many. One of them is the fact that we are also many in the country. Yes, we are many, but that could be converted into an advantage. If you are a large-scale farmer, you have the market to sell your food, your production. So this issue of lack of food security has many, many dimensions. And we can go ahead and look at the different dimensions and then look at them and try to work out some of the best ways. Government policies are very important to support the farmers to produce more. 50% subsidy. Or any more questions? I saw some hands there. We will continue since we have all the time to talk.
Okay. Good afternoon, sir. My question is on this wastewater reuse.
Wastewater reuse?
Yes, sir. And the question is, what type of water can we regard as wastewater? And is there a scale or threshold for each plant, or is it general something? And lastly, is there any technique that a peasant farmer can use to reuse a wastewater?
Okay.
To treat
water
wastewater for reuse. Yes, sir.
Thank you. Yes. Thank you very much. Definition of wastewater. Let me give you an example. Let me give you an example. In your kitchen, in the house, when you finish eating, you go and wash the dishes. Where does the water go? It goes into the drainage. That's what we call wastewater from the domestic. That's one type of wastewater. When you go to the toilet and you flush the toilet, what happens? The water goes to the soak away. In more organized cities, it goes into the central sewer system. Okay? That is collected somewhere and treated. Okay? And the water treatment processes are many, depending on the type of waste that is within the system. That's one. The other one is when you have a tomato processing industry, for example, you use a lot of water to wash, this, clean that, and you throw away some water. That's a typical example of industrial wastewater. So we have different kinds of wastewaters: domestic wastewater, industrial wastewater, and of course we even have agricultural wastewater. When you irrigate, the excess water goes into the drainage system, isn't it? If you don't have an adequate drainage system, your land is likely to deteriorate much faster than expected. So agricultural water is also, in agricultural practice also produces wastewater. So this wastewater can be collected and treated by so many processes. Initially, maybe you can remove all the solid parts. Then you can now go and add chlorine or whatever it is to reduce the odor. You do all kinds of things and then produce water that you can even drink again. Okay? Or you produce the water to a certain quality that you can go back and apply it to the land for irrigation again. So that's the first part of the question. Which is the second one? Threshold for each plant. For wastewater, it is the same quantity that the crop really requires, whether it is wastewater or fresh water from a borehole or from your dam. The water, all the crop needs is its own water for its own physiological processes of transpiration. And it does not matter whether it is wastewater or borehole water or whatever water that is there. But the use of wastewater sometimes may have an additional advantage over the others because it may be richer in nutrient contents than the others. Okay? So sometimes the use of wastewater can even be more advantageous. It can reduce your fertilizer requirement, in fact, if and when it is treated deliberately for the purposes for which you want to use it for, in terms of irrigation, and for selected crops too. Okay, sometimes we don't want to use wastewater for crops that are going to be eaten raw. Okay, like vegetables that can be eaten raw. We only produce crops that can be processed before consumption. Okay, so there are many things to look at when using wastewater for irrigation purposes. We call it wastewater recycling. Okay, you can continue to use the water and water because law of conservation of mass, if you remember. Water is not lost. Only thing is that it changes form from one form to the other. Okay? Anyway, yes, please. Last one? Is it the last one? No. Oh, which one is the last? To treat water. Well, depending on the type of wastewater, one would not recommend you handling domestic water from maybe the toilets, for example. Because the technique of handling it is more complex and therefore a bit more difficult and dangerous. But any other water, you can use simple filtration. Sand filters are available for you to be able to filter your, what we call light wastewater. Okay, light wastewater. When we say light, it's not the one that is heavily infested with bacteria and pathogens. Okay, so you can use sand filters and many other types of filters to remove at least the solid part, and you can convey the water to your farms. If you go to some integrated farms, you see people having fish, poultry, and some irrigation somewhere. So when they harvest the fish, they put the water into the fields. That one, you have to be very careful too. If the water is not pathogen infected, you can push it to, at least if you are growing 3 crops, it's safer than growing vegetable crops. Okay? Thank you.
Good afternoon, everyone.
Good afternoon.
Mine is not question, just but contribution to my brother question.
Good.
That talk about fertilizer.
Mm.
You can also use poultry manure at the beginning after you make your bed preparation. You mix the poultry manure with your loamy soil before making your bed. If it is in greenhouse, you mix it very well. It should be mulch or at the same quantity with the loamy soil and the poultry feed before making your seed bed before transplanting. And if it is open field also, you can also mix the poultry manure. And you can also use the 2 types of fertilizer, maybe after you transplant, like the NPK. You can just apply it close to the plant, but like 2 centimeter spacing, so that the NPK will not burn the plant, the crops. Then you can also use soluble fertilizer like the calcium nitrate. You can fertigate. You mix it in the bucket. Then after it has dissolved, you now pour it inside the tank. Then as you are irrigating your crop, the plant are also getting the fertilizer from the water.
Thank you very much for that contribution. But I want to sound a small word of caution on the use of poultry manure. You really need to subject it to this composting process, because it is highly, it has high levels of nitrogen and so on and so forth. So if you apply it directly, you may have quite a lot of negative effects. So it has to go through some composting process to reduce I think the uric acid that is in there, in order to reduce its effect on your crops. We have not even spoken about composting, using organic materials. You can do a lot of composting. All the waste from your kitchen that is not proteinous, you can pile them in a pit over time, and after some time, that will be very good fertilizer for you at the end. But do not put anything that is meat or poultry product. Otherwise, the odor will be unbearable. Yeah, so that composting is one area of doing fertilization. And it's very useful for these micro irrigation systems that we practice at home or even in our backyards. Okay? Any more questions? Yes, more? Yes,
Prof. In the course of answering my question, this question arises.
Yeah.
With our local farmers, we know they have their own local knowledge due to years and experience of practice. So I recommend in such a way, if those local knowledge can be documented and also validated as compared to science at their own level, they make use of those knowledge and it works for them. If there's a way we can document such knowledge because of their years of practice,
okay,
it will go a way in order to sensitize other farmers to adopt such before we get to the advanced use of smart technologies and the advanced farming of irrigation?
Yes.
That's my concern.
Actually, somewhere in the slide, I don't know, I can't recall. There's a place where I mentioned upgrade traditional indigenous knowledge. I think I heard Professor Igbadun saying this yesterday, that don't think that the farmer is stupid. Go? The farmers have their own knowledge. Only thing is that they have not documented it, but it's working. It may require some upgrade. Okay? But don't assume that what he's doing is entirely wrong.
Even UNESCO recognizes such knowledge.
Of course, you have to recognize
citizen science.
Exactly, you have to recognize indigenous knowledge, and as a challenge for you now, you can begin to study some of these available indigenous knowledge techniques in order to improve them and apply them in the particular areas where they emanate, and even try to advocate for other areas. So it's another research challenge for you as a young professional in the sector, that you can put efforts to see that some of this indigenous knowledge are identified, documented, and upgraded for adoption and practice. Okay? It's something that is quite in order, I believe. Okay, so we seem to have exhausted the questions, so I don't know what is the next thing that we do.
Okay. Thank you. Please, round of applause for him. Thank you very much, sir. A round of applause for everybody here. We are the real MVPs. So right now we have come to the end of the presentation for the program. And we'll just have an interaction section. We'll just talk about, things concerning the slides, starting from yesterday's presentation, what we've learned, maybe just network, because that's what the young professional entails. We promote knowledge and networking opportunities, and basically that's it. The questions that maybe wasn't clear, you can ask. The resource personnel are here, and we'll wait for the lunch to be ready. So let's just interact. Maybe just know ourselves more. There is Dr. Mukhtar here. He's from Burkina Faso. Maybe you can ask how they do their, how we can adopt. Yeah. So please, let's get busy, please. Thank you. I appreciate everyone, actually the resource personnel. Everyone here, we thank you for, on behalf of the young professionals. Thank you so much. Yeah, sorry, for those that don't have the slides. Yeah, the yesterday slides has been uploaded on the WhatsApp group. So if you're not part of it, if you've not been captured, you can write your number, then you can be added on it. So the slides, yesterday, not today, but today will be sent to the group. So yesterday is on the WhatsApp group, so you can view it, then ask questions, they are here. You can even ask for their contact in case for future purposes. So please, let's just interact, know ourselves better. Our ICID president is here in case you want to ask. Is it So please, thank you. When the lunch is ready, I will notify everybody. Please, is there any other person that is not on the group so we can add you?